Şimdi sen Kapıkül'de mi kalacaksın sen? Ha. Tamam oldu. Kaçta gelirsin? Perşembe günü. Saat kaçta? Sana bir şey telefonda internet var mı? Telefonda internet var mı? Evet. Yoksa canlı yayına çıkacağım. Bakabilirsin konuşma yaparken. Yani şimdi ya da yarım saat, bir saat sonra başlıyoruz.
It asks me if I want to scan this device, but it's in French. And I cannot
just send it. You can
okay.
Est-ce que tu vois la session sur la session? Ça, c'est un peu...
Ah, on va nous voir. On va nous voir. Ou on voit l'écran.
En fait, on voit exactement plus que toi.
Ah bon. Ça, c'est ce qu'on voit sur l'écran. Et on voit un autre.
I suppose paste is for left and front. I will go paste that in desktop.
There's a folder on the desktop.
Inside here?
Yeah.
Okay.
In which part you are, but...
I have in this folder both presentations for Dionys and tutorials in the end. Is that okay?
Maybe you put them in
Okay. So this one. Here?
Yeah.
And sorry for that. I'm not sure where should I place the rest.
In which part would you be presenting these two?
Let me ask.
Okay. Yeah.
To be sure. T'as quitté la présentation ou pas?
Juste une en ce moment à l'instant.
Alors du coup, tu vois.
Not here my presentation. Just a sec. Finishing.
Non, toi t'avais mis un
il avait mis ça là en vrac, mais je lui ai dit, mais il est dans les trucs, mais il sait, du coup, il sait pas dans quelle partie il est.
Three files.
Yeah. No, it's off.
It's off. Okay, there are three files.
Yeah.
The VDL presentation is with for the use cases.
Okay.
Okay, so VDL will be in use case.
And
the Word Package 6 is with the three Word packages, not the training session, the other one.
So building blocks.
Okay.
And the other one I placed it on the tutorial.
Okay. So we have one in the building blocks, one in the use cases, and one in the tutorials.
Yes.
Right.
If you could place LMS, just to be sure that we...
Nice to meet you.
To meet you.
This,
And David, probably.
nice to meet you as well. So you will cover the presentation for today.
Yeah, I will cover the presentation. At the morning, I will try to explain our perception analysis.
Are you alone or
Let me
is
go
also-
Yeah.
Okay, sit down. Now,
Hey, Dionisio, again. Nice to meet you again.
How are you? Look, Sidro.
Hi,
It's Costas.
Costas. Nice to meet you. At least now I know who you are.
the person behind the camera.
Yeah,
Put the face on the...
yeah, of course.
A la cola.
A la cola. Vale, vale. Sorry.
So we are okay with the three presentations.
Yes. I was finally at the testimony. Very hard.
Yes.
Just a second.
We have a demo now. Right. Check it. All right. The calibration was smooth.
Okay.
There are some
we have a folder open.
issues
But
with the irritation, at least what Costas mentioned.
Yes.
But
We were speaking, Claudia and me, about this issue that we couldn't do too much because it was developed by Adriana, our workmate that lives in Ireland. So I don't know.
I understand.
thank you.
There's people changing, right?
Yeah.
To keep people for the project.
Yeah. Yeah, not only I mean, yes, but in EPCL as well. I don't know if about you had.
But we didn't have this issue, but we used to just 1 year ago, so
Yeah.
it was short for us.
Yeah, of course.
I guess
So-
they fellows, so people left, but yeah, it was a different story. But those things complicated. So Vito, that's the meeting person.
Okay.
I think we have meeting 7, the kickoff meeting, right? You were with TPF.
No, wait, kickoff meeting, I was not there.
You were not.
I was not there.
Okay.
So maybe you met my colleague, I think there was Sylvain and Alf. So I was.
I remember it was
This
one. So, amen. So this is the one for the tutorial.
No, this is for
Sorry.
at the night for
The building blocks.
no, it's 10:40, I think.
Okay.
At the morning.
In the morning, yeah.
We will talk all about work all algorithms in work package. We won't only talk about implementation. We will talk about fabric algorithms. Briefly, not a problem.
Yeah, perhaps if there is some time today, tomorrow with Mohammed, we can also have a chat.
No.
Last week, so all the details.
Okay.
You will?
He was
Oh, you will.
Okay.
You will that, you will that.
So
My turn?
Yeah, your turn.
Yeah.
Te acostumbras. París es maravilloso los 5 primeros días, luego te hartas y luego ya dejas de ir.
I have a lot of things inside, so
Please let me know.
O sea, tengo 4 niños.
this presentation and the video
And this one is for Mark.
for Selmark, yes, UGDL, not for Selmark use case evaluation now in the morning.
Mark.
Yeah.
Okay. So yeah, it's use case for some
Yeah.
mark, etc.
Sí, que no sé, de vez en cuando.
Now at 11:45, I think, from 45 to 12.
Yes, perhaps.
Vemos
And the video, please. I don't know if we are going to have enough time to show it, but
You can show the video.
Let me know where it is.
era.
So Mark, perhaps.
no.
Hemos estado 7 días, ha llovido 5 y aquí no voy.
Where is it?
Sigue intentando contactar.
This one, sorry.
This one.
Selmark complete. Yes.
This.
Yeah, perfect. Romain.
Okay.
Yes, maybe.
We can show this in the afternoon. We have
I can use it as well on the afternoon because it's a good thing to present now. What's happening? Too much.
No, you have to pay.
What?
No, close.
Maintenant? Not yet?
Not yet. Close.
Okay.
Left button. No, sorry, right button. Open with. I don't know who is this.
Open with.
Yeah.
Abrir a ver.
Yes.
BL.
BL.
Should be.
Pues sí.
Yeah.
Okay. Okay. We don't care.
We don't understand.
We don't understand.
Not a lot.
Oh, very nice.
Yeah.
This is
Just to remark something more what we are working on, where we are working on. Sorry.
Okay, perfect. I think it works.
Sí.
So,
It's working.
so you have to drag and drop
Right.
the other one.
Yeah. No problem. This is the computer we are going to use. Right.
Una pequeña, pero de esta todavía. Además es un disco que es de hace.
Okay.
My
Yep. Send.
Sí, tengo que preparar la presentación. Bueno, algo tengo que buscar para saber qué es lo que voy a presentar. Okay, thank you.
You're welcome. See you. Hello.
For me, I'm not going to have any slides. I'll just do it a cappella.
Okay. Very good for you. And you are.
Je suis de CA.
Okay.
Je suis le chef du chef.
Greg, c'est vous? Non, ils n'ont pas donné de nom, mais ils ont fait référence à un Greg avec un présentation.
Ah oui, c'est bien ça.
Je présume que c'est vous.
Hi, hello, Isidro. I don't remember. Andreas, yeah. I remember you being with us in Iman at the beginning of this year. Too many people for me. Hi, Isidro, sorry. Con Iman.
Gregorio.
Sí, que estuviste hablando.
A Cotton Casco. No me digo Gregorio.
Okay.
Encantado.
Vous êtes un grand Flora was my baby.
Oh.
Greg. It's Greg on the
No, for I'm working floor, I'm working with 15 years.
my deputy. She looked
Okay,
at the
okay.
we started this thing together. I remember that we did the trolley for the robots.
Yeah.
That was the modular.
Yeah.
I invented the name.
You?
Yeah. But there's a story behind it. So the name of the name, I proposed it.
I actually have file presentation for this morning.
Ah, nice. No. Yes. So please, if you can.
On ne peut pas avoir de nom, pourquoi pas. J'imagine dans les journaux, PSA met les marmots à travailler sur les lignes de production. Et donc, elle dit, ok, invente un nouveau nom. Et donc là, j'ai aplati la queue.
EPFL?
C'est ça, j'ai aplati la queue.
Thank you very much. So you have extra time for the second presentation. You know, normally you have blocks of, let's say, 20 minutes, I guess. For you, you have more time because you present EPFL and you don't take your technology.
Okay. Thank you. Okay, but it's okay. I know it quite well. So, but thanks for the extra time. It's always helpful.
Sure. Just I need to double check. We need to double check how much time you have.
Yeah, but I think it's okay because I know the technology quite well anyway. So.
Yes, I think so. Because you were a postdoc at EPFL
I
at the
worked
beginning.
there as a scientist.
Okay.
C'est Raphaël, c'est ça?
OmniGrasp, Amen, LMS. Okay.
Shall we check if it works, the EPFL one also? Like
Yeah,
videos
sure.
and stuff. I think this video works.
So, we have to check with. We have to check. Looks to work.
Seems fine, yes. Imagine it's gonna be okay.
Okay.
Just the USB.
Okay. Oops. Okay, should be okay.
Maybe just closing the PowerPoint would help.
Okay, so it disappeared.
All right.
Should be okay.
It's not gonna explode. Thank you.
Je pense qu'ils sont en train de finir.
Baptiste, il peut te présenter.
Parce que du coup, en fait, on a déjà fait plein de
Je verrai bien, je m'entends si prépare sa présentation.
ça veut dire que ça notre échange, je trouve.
Moi, je peux faire plus court. Ça rattrape un petit peu sur la journée. Pas facile. J'ai 5 minutes. Bon, j'ai répété dans la voiture. Souvent, j'arrive pas à faire plus long que 5 minutes. Ça va très bien.
J'ai cherché les participants. On a le droit de sortir sur les drapeaux en plus.
C'est le deuxième écran qu'il faut. Je croise les énames. Il va falloir que je me mette là, n'est-ce pas, parce qu'il y a des gens à distance.
Oui, il y a des gens à distance, donc il faudrait que je sois.
Alors, par contre, il y a un sujet, il y avait un sujet qu'il faut qu'on traite sur Livestorm. Tu l'as regardé ou pas? Parce que du coup, en fait,
Là, c'est bon maintenant.
C'est bon?
J'ai corrigé.
J'ai pas vu que ça fait pas, j'ai fait un WeTransfer.
Enfin, oui, transfert. Du coup, nous, on regardera ça tout à l'heure. Ce que je propose, là, on va commencer la journée. De toute fason, ta présentation, ce sera tout à l'heure. On va regarder ça à la pause, c'est bon?
Donc, normalement, le micro et... Ouais, micro et caméra, c'est bon. C'est bon. Et puis, je sais pas si on peut pas démarrer Livestorm sur ton PC.
Non, pas encore. On va regarder ça tout à l'heure.
Ouais.
Je te propose qu'on lance là. Et puis. Okay, thank you very much everyone for attending this workshop. So this is the final workshop of merging. So I'm very pleased that IPC is organizing this workshop, and we are very glad to be here. And thank you very much, CEA, for welcoming us here at CEA East. First of all, I would give the floor to you, please, for a very short introduction about CEA and so on. Please, thank you very much.
Thank you. And I will make it as short as possible. So welcome everybody and good morning. Benvidos os galegos, que me políjaro menos non me dopera más disas. Welcome to all the people who made it here in person. Thank you for all of you who are also following by distance. My name is Greg Amiyugo, and I'm the head of the AI and Robotics Division at CEA. And I should be looking into the camera. Okay, it's a problem because I have real people in front of me. All right. So I'll just like to say a few words, especially for those who walked through the forest this morning at their own risk to get here. So you are at CEA, and you're in Saclay, and Saclay, some people have called it the French Silicon Valley. Yes, it will probably never be a Silicon Valley, but the government is certainly trying. So you're in an ecosystem, a local ecosystem, where you have concentrated in a radius of 20 kilometers, 1/4 of French industrial R&D. And it's a powerful ecosystem with both companies, universities, and research centers. They forced everyone that was in Paris to move out here, so we're not alone anymore. But CEA has always been in Saclay. And a few words about CEA. We are a research institution that was created by Marie Curie's daughter at the end of World War II with her husband and with General de Gaulle. So you could say it was an unholy alliance. And the reason was to have France be able to exist after the war. And that meant strategic independence. So we are the ones that were tasked with making the atomic bomb for France. And also energy independence. So that means nuclear reactors. And over time, we grew, and we were forced, because of the technical challenges, to develop new technologies. Eventually, the government said, you need to use these technologies to help other industries as well. And that, to reassure you, is the part of CEA where you are in today. It's called the Technology Research Directorate. And we are some 5,000 researchers that work with companies in every industry. And our mission is to develop technologies and transfer them to industry, to make them more competitive, environmentally sustainable, and that's something that we have close at heart, also more human. So if we finish our Zoom, today you're at the LIST Institute. And LIST is the Digital Technologies and Systems Institute. That's the 3 buildings that the people who are here see around us. And that's 1,000 researchers that work on software, systems, and also physical systems. Like, of course, the most beautiful ones we make are robots. And for those of you who made the trip today, I think that you will have the opportunity to see some of the things that we are doing. Now, I don't have much more to say. It's just that I think this workshop is particularly close to heart. I would like to congratulate you all for the work that we have done together on the project, and I have been following it. I would like to congratulate Christine, because I think she's been very sadomasochistic to take the project on. It's been very difficult at times, and I know that. And sorry we couldn't help you more in some of these difficult times. But the project itself, working together on one of these final frontiers of robotics, because it is one of the final frontiers of robotics, is something that's very important to us. It's one of our main research areas in robotics, and one where we see that humans, robots, and AI are coming together. And it's been really interesting to have this project during the time when the segment anything models come out, the OpenX models came out the other day, we have a feeling that everything is changing all around us while we are trying to push the frontiers of grasping and especially soft objects. And I think that we have managed to do a good job regardless. And then the final message is it's not just about using AI or about software capabilities. It's also about making things that are robust and reliable and that work in industry. And I think everyone that's involved in this project has got that particular thing in mind. So I will be on and off during the day. I'll follow what you have to say. And again, I'm very happy to have you here. So welcome. Thank you.
Thank you very much for this nice introduction. So I would suggest that we go for the, before we go to the introduction by Christine, I would suggest that we have some points regarding the agenda of the day and some technical aspects of the day. Okay. So as you can see, there's people in the room and some people who are attending remotely. So, issue. Okay, so just to go to the agenda, so we will have 4 sessions. So the first one will be a block of introduction mainly by Christine and also by NMS. And also myself will make a short introduction regarding the general value chain of merging. Okay, and after that, we will have 4 presentations regarding the building blocks, the building blocks, okay, to all the technology development we have done during the project. And after that, we will have at 11:30, we'll have evaluation of the merging technology on the 3 industrial cases. So let's say VDL, Cellmark, and Timonier. Here we will have the lunch session. So lunch is not only lunch, there will be also a poster session. So you are invited to go and visit the posters in the other room over there. What I miss is all the presentation will be done in that room. There will be poster on the other room. And there will be for sure, there will be some visits also where it will not be webcasted, the visits at the lab, etc., etc. But all the presentation will be here, and the presentation here will be webcasted. Okay, and in the afternoons, we will have 2 parallel sessions regarding tutorials. One here, one session here, and the other one in the labs for CA technologies. Okay. Okay, as I said during the morning, just to give some details, we will have 4 presentations, around 20 minutes, except for Omnigraph, who will also present EPFL results. And after that, as I said, the 3 use cases. Please keep in mind, on your badge, you should have 1 number and 1 letter. This is for the people attending the meeting physically. So here the number is for the visits. During the lunchtime, we will have visits of labs. So we will be divided into 3 groups. So the number is for your group. Will be invited by someone from CA. And the letter is for the tutorial. As I said, there's 2 parallel sessions. You cannot attend both sessions. So please be careful of your letter. And if you don't have any letter, please come and ask for a letter for a group. Okay. Last things I wanted to share with you. We have organized a questionnaire. As you know, we are finalizing the merging workshop. We are currently making some assessment regarding the dissemination and exploitation plan. So, and we need to have, let's say, identification of pains or bottlenecks. So here you have a questionnaire we have set up. So please fill the form. It's very useful for us to have your feedback and how we can think of future application of all the merging technologies. So it's only 10 questions, no more than 5 minutes. So please fill the form. So that's all I wanted to share with you regarding organization. I will be here all the day, so if you have any question, please feel free and ask for any support. I will leave the floor to Christine, unless there is questions. Thank you, Christine.
Même il faut que tu le tournes dans la fenêtre.
Mais je l'ai tenu,
Ok.
Je sais pas si c'est. Hello, everybody. Thank you very much for joining us for this meeting today. So as it was planned, so the objective of this meeting is to make a point about the final results of the merging project, which is a project which was funded by the European Commission during 4 years. And which deals with the manipulation and enhancement through robotic guidance and intelligent novel grippers for the manipulation of flexible objects. So I will now make an introduction to soft materials manipulation and the robotic challenges towards emerging use cases we considered. Based on the World Robotics Survey of this year, we can see that the handling is the most important application for the robotics in the industry. Nevertheless, when looking at the industrial robots by customer industry, we can see that manual machine feeding with bulk anti-pouches, and for the wet feedable ones, the objective was to position large grass fiber textiles and fragile foam blocks. So it's a very large view. You will have some more details in the other presentation of this today meeting. Each of these use cases can highlight some very specific robotic technical challenges. For example, we can mention the handling of multiple variants of plies, the stacking of partially paired fabric pieces, wrinkle detections, insertion in rail, or low accessibility, large parts, different material shapes, and so on. To be able to solve these different use cases, so merging propose different solutions, but they all can converge into a general concept, based on, firstly, the industrial requirements, which we consider were the most important in the flexible material handling. So, firstly, the handle of soft parts without damaging them, to be able to have an easy and fast work cell adaptation to soft product variants, and adaptation to non-expected situations, and the possibility to deploy plug and produce system for multi-product variants. So the merging technical solution were considering firstly a gripping device which were equipped with electroadhesive skins that conforms to the objects, or multi-purpose grippers. They also considered robot system programming accessible to non-specialists for easy robot programming, robot skill optimization, and intuitive collaborative handling. And we consider also perception and supervision function in order to adapt the system behavior in real time to the conditions. For example, we focused on digital scenes for decision making, and robot behavior adaptation, multi-level perception for the environment understanding, considering the human and also the flexible part. And then also we refer by modeling to the prediction of the flexible part behavior. So this illustration shows in a very short way what are the different technologies on which the different partners of the project focus their work during this 4-year project. So the partnership as a whole, we were 11 partners. We consider the entire value chain of soft object gripping automation. So from techno provider through integrators to end users. So we were 5 RTU, 1 techno provider, 2 integrators, and 3 industrial end users in different countries: France, Switzerland, Greece, Spain, Italy, Netherlands, and that's. So thank you very much for your attention. So thank you also to Dionysis, who is the technical manager of the project, and then a last acknowledgement to the European Commission who funded our project and allow us to work on these very interesting subjects. So you will have, so as I said, a lot of details and a lot of explanation regarding all the technologies that were developed, but it was just a first introduction in order for you to understand what were our objectives and how we consider this specific research subject. So thank you very much to all, and have a nice day, and welcome once more to this workshop.
Yes. Thank you very much, Christine. You're perfectly on time. So sorry for people attending remotely. So we have a technical issue. We are waiting for our expert. So you will be just able to see me and not my slides. I'm afraid we will fix it in, let's say, 5 to 10 minutes. I'm afraid for that. But anyway, you should have the content of the presentation. So what we will share now is a topic regarding the value chain of merging. So it's just a brief presentation about, as I said, the value chain and a few items regarding the exploitation plan. As you know, it's a public workshop, so we cannot give, as you may understand, that we cannot provide too much insight about the exploitation plan of the project. So, but anyway, we will provide some feedbacks. So here you have the overall project methodology. So we started from at the beginning here, at the very early stage of the presentation here, with specification from end users, so VDL, Selmark, and Timonier. We were working on the technical building blocks for both the gripper and also all the I would say the software building blocks. Then after all, we were working on integration. So we have partners like Timonier for the physical integration of the gripper onto some kind of mechanical systems, but also from CASP we had also some software integration. And then after that, this is what we done recently. We had on-site demonstration and also assessment of the performance of the merging technology. And now we are here at the very end stage with the exploitation of the results. So starting from TL 3 to 4 and into TL, let's say 6 to 7. So here we have simplified value chain. So for sure, we did much more during the project regarding the value chain. Here it's just some insight we can share with you for our public workshop. So here you have, on top of this, you have the gripper. So the physical gripper, I would say, developed by Omnigraft. And here you have the building blocks for software building blocks. So everything, as I said, everything is wrapped into an integration system. So both software integration and also physical integration. And as we were speaking about value chain, for sure we have the customer. And in the project was represented by AMN, by VDL, by Selmark, and also Timonier. Sorry for that. And regarding the trends and the market size, so we already had some insight by Christine regarding the market, but at the beginning, what we were seeing is there's a growth on each market. I don't want to go through all the details because I'm not sure that it is relevant today, but what we can say is there's a very strong growth, let's say ranging from 10 to 22%. As an example, for textile robotics, 22%, it's a very huge growth. What we can say is that the needs, for sure, as we are working at IPC on composite market, for sure we will make a focus on this aspect. There's a strong need for automation. There's a strong need for producibility, for increased throughput. Lots of requests regarding this aspect, better quality and reduction of labor costs. And more or less, this is what also we can, on the market side, this is what we can expect, what are the trends now. And also from the technical side, there's also a big growth as it is displayed here. So at this stage, we are working also on the value chain and expected incomes. So as you can see on the slide, what we have worked here, we have some building blocks, we have integration of the building blocks into softwares and physical integration, which might make some direct sales. So let's say here is the income stream for the project. So regarding the project, we have identified 18 results, and we have also identified 4 key exploitable results. So let's say valuable results that can go to the market. We already have identified some markets, so textile, flexible packaging, and composites. And today we are making some interviews just to fine-tune and also to go in details what are the markets, and if we can extend the market opportunities or deep dive into some segment of this market where the merging technologies might have some added value. So Here, some ideas we had. We are targeting film for agriculture, protective products. Let's say here you have a kind of plastic foil around the engine of an aircraft. Also, what we call kitting companies for composites, but we have the same for clothes industry. So the companies who are making the cuts and then transferring the cuts from one company to the other one where they will make the assembly. And also we are discussing with some technical experts regarding technical textile and also end-of-life textile. End-of-life textile, let's say I have a textile coming to end-of-life. Can I reuse this textile or should I go to the recycling? So this is topics we are discussing currently. Again, we need to have your feedback regarding the insight, regarding regarding how to extend the potential application of merging. So please take time and please go to the form. You should have, all of us, we should have the link to fill the form. We need your insight just to fine tune where we should go for the next stage of merging application. No more than 10 minutes, no more than 5 minutes and 10 questions. So please take time and we will be happy to have your feedbacks. So I guess we are perfectly on time. We have time for 1 or 2 questions. So if you have questions from the audience or people attending remotely. Okay, so we have a break now. Let's say let's meet at, if I'm not mistaken, at 10. We have 15 minutes of break. So there's a coffee and the poster on the other room. Please follow me. And for people attending remotely, let's meet at 10. Thank you very much for this first block of presentation. See you in 15 minutes.
Sorry for being late. I hope you found some time. I was a little bit late today. Yeah.
T'as vu ça?
J'ai vu, mais je l'ai pas répondu après.
Ah merde.
Yes, the trip was nice.
No problem at the airport?
No, not at all. We arrived yesterday, we have lunch there. It's very, for us it's early in the morning, and after we came here by taxi.
Ouais, tu y as un intérêt à présenter la version.
Yeah, it's very close as well because we came here today. We have
It's a difference with the weather.
Yeah.
It's a difference with the weather.
Yeah, but 2 days ago, we have 10 degrees more.
Yeah, Romain said me before.
Well,
It changes suddenly.
last week we are in the
Yeah.
in the beach.
No, not us, because we do not have the sea.
Ouais, parce qu'il y a un truc
It was very hot also.
je veux dire que c'est parce
And
que
the
c'était pas
grace
si...
in 2 days.
C'est robuste et...
And now, yes, we have a couple of workshops to present, and we noticed that we have another workshop in the afternoon. We have a misunderstanding with the names. Yeah, I think so, and I have to prepare it, but I
You
will
have
try.
something, or maybe you can switch. Take some elements you can present it into the afternoon, see that was more.
Yeah, we try to present some videos or something like that, because I'm not very technician about the DC on computer, but I will try to use that.
There are some questions about
And how is it
Tu peux
about
le dire, c'est ça.
the technical demonstration?
Qui était...
Where-
C'est beaucoup de contenu, non, c'est ça?
you are reaching the-
Parce que t'as que 20 minutes, c'est ça?
What's the state now?
Now the robot pixel is working with the grippers
sauf qu'après,
from
il y a eu
Omniglass,
des-
but not with electroadhesive, because with
Mais
electromagnets
pour les contenus,
we
il
changed
y a
it.
des pavillons.
It was our big plan because
Ça, c'est ouais, effectivement, ce qui était
finally
maintenant. Il
they
y aura des oreilles dessus, donc
gave
pas
us
que
the
c'est
final version of the grippers very late.
Yeah, they are coming to website.
Yeah,
something.
so it was impossible to deploy
Sure, yeah.
correctly
Yeah.
on all of the.
C'est quoi le moyen plus
Now,
pratique pour mettre une présentation sur le PC?
Clé USB. C'est vraiment le top. C'est un peu old school, mais c'est encore ce qui marche le mieux.
It's more or less, yes, it's more or less working, and what I don't know if we are finally going to record some professional
Très bien,
videos.
vectorise,
because
teaching, en fait,
we
c'est
have
intéressant pour
another
ça, pour
issue,
apprendre des voix.
another issue, no, we have an important event
Ici, tu
at
es
Ivan this week,
Ouais.
and these people who usually work with us recording videos are just working for the laser event.
Non, mais c'est-
Sorry.
C'est en fait, tu peux
I don't know.
utiliser la méthode Julie, des trajectoires déjà prises.
Yeah.
Along the project.
Yes, for me it was very hard because I started really
Yeah,
to play
sure.
with the ever live item and
Ouais.
oh,
J'ai une présentation.
really, I was an integrator. Yes, my work is working with my hands and with my head. Okay, like any other technician, but coordinate from that. So now this project is not a coordination; it's just handling.
Yeah, sure, but yeah, I understand
La
the
matinée,
word
quand j'annonce 3 noms.
situation.
Alors j'avais un...
Il y a de
Frédéric, ouais, il était là, ouais.
we are
C'est Frédéric.
many people who are using their institute were
Yeah.
replacing each time I had to remind
Je peux laisser ces
just
slides-là
to
pour les
explain things as it was a start
Oui,
of
oui,
the
oui.
session.
Yeah.
And as
Le
you know,
le réseau qui a sauté.
you had to replace it with,
Donc normalement, je me suis mis en...
like, nearly all
Normalement, je me suis mis
the
en
staff
Wi-Fi.
said they want to
C'est du coup, il n'y a plus de réseau.
Tu t'en viens un câble?
Non,
Tu t'en viens un câble?
non, c'est gentil.
Il prend de son...
So I hope now next week we'll only ask the team when they come. And last week come inside
No, they started last week.
yeah.
Last week. They were
I
there.
thought it would be it's a
Yes.
And so now with their people,
They worked. We have a video working with the robots inside of the press, grasping with electroadhesive as well, but just that.
Yeah, sure.
Just that. We couldn't deploy all the robot movements along the. It's not very robust because we don't pay attention.
Ouais, mais du coup, c'est pas le nom qui va partager.
Inside of the press.
Tu peux mettre juste une façon de l'écran.
Oui, c'est ce que je pensais avoir.
Yes, because
yes,
it's performing. So.
we missed when we
Yeah.
all the specifications.
Yes, I don't know.
So it's evident, but we
Yeah.
Sur le double écran, quand je le mets en je le force en simple écran,
Tout souvent, on laisse comme ça, et puis
ouais. Et puis il faut juste appliquer sur.
je suis en train de cliquer dessus là pour l'instant. Timoni nous a fait une présentation de 300 mégas, donc ça.
Moi ça arrive.
Ah, 300 mégas.
Ça va vite avec les vidéos.
Ouais, c'est clair. Tu peux pas l'envoyer directement sur PC? L'envoyer directement sur PC, je sais pas si vous êtes en réseau.
Oui.
Et là, t'es en Wi-Fi. Hein. Je suis en Wi-Fi.
Oui, avec le tien Wi-Fi du coup. Enfin, avec. Non, c'est bon, il s'est reconnecté sur notre.
Ok.
Ouais, j'ai accès. Ouais, c'est bon. Je mets dans le projet Emerging, c'est ça, pour échange?
Tu me dis, sinon on va essayer de retrouver notre idée.
WP9 pour échange. Qui m'appelle Pierre-Yves. Je répondrai tout à l'heure. C'est pas urgent.
Donc là, c'est le grand chef là?
Oui. C'est pas le grand chef de liste, mais c'est juste en dessous.
Ah ouais. Donc un petit quand même.
Ouais.
Ouais,
Enfin, il est super. Moi,
ouais.
Si tous les chefs comme ça.
Ne sont pas de ça.
Non. Mais il est de la région des gens d'Aymen.
Ouais, j'ai vu qu'il avait parlé espagnol aussi. J'avais un souvenir. C'est la première boutique que j'avais faite là. Je me souviens parce que je crois qu'il y avait un registre, ça se trouve.
Oui.
Et des fois, il n'y a pas ce que je dis.
Je coupe ton micro.
Tac, ordinateur, d'avoir une clé USB quelque part là-dedans. Celui-là? Non, c'est pas ça. Pourquoi?
Il faut quelques secondes pour le trouver.
Yes, it's working. It's working. What we have to improve as well in the future is to add another fixed camera because we use it only two
C'est un truc à la
cameras.
noix. C'est le truc qui bouge là-dedans.
Yeah, so it sometimes
Annulé,
stops
enregistre pas.
working and it's not very stable.
And the recon remover is
The recon?
the virtual remover.
Yes, but finally we didn't need it on the inside of the press because when the robots
comment?
yes, in flat, finally.
C'est d'ailleurs le fichier 23.17 de Final Version.
Alors, tu l'as mis dans quel répertoire du coup?
Yeah, of
Dans
course.
workshop public,
Yeah,
Emerging.
but not with the grippers, with the Omega grippers because of that, because it's very sensitive to the heat. So with another kind of grippers, yes, we can pick and stand the fabric. It's not very quickly because we need to move in with several movements of the fabric.
Yeah, there is a strategy and different points.
Yeah, so
move one of them.
yeah, this is one point as well to improve. You can compete against a human operator. Because it's
Important gap in this moment.
that's true. This is a prototype.
Workshop public. Et c'est lequel des deux?
Final Version.
For me, it's good, but I have to prepare. I would like to prepare the presentation of the afternoon at least. Thank you.
Thank you for coming. I hope you will be ready also for the presentation.
D'accord.
There's also
Yeah,
the questions.
Received an email.
Yes.
I would suggest you. I don't
sur le rayon, hein.
see the question, but that
Ouais, je suis sur le bureau.
I look there. I look at the question.
Ok, d'accord. C'est quel On va rajouter un CEA ou je sais pas quoi.
C'est celui-là.
But the rotating is in the.
It will be there.
Okay.
We will put some chairs.
Okay.
Okay, because for us it's a little bit
Good afternoon.
Okay.
Merci pour les
J'y retourne là parce que hier soir ils n'ont pas voulu me les faire.
Ah, merde.
Parce que Yann m'a tenu la jambe pendant un moment et quand je suis arrivé, c'était trop tard. Il y a le temps qu'on démarre là. Le temps qu'on démarre la machine, tout ça.
to rush out and do our best in the short time available to develop two gripper prototypes that could be integrated with the other building blocks and could successfully grasp those challenging objects by using the electroadhesion skins that were developed by EPFL. Big thanks to my colleagues and collaborators who all contributed to this. Since the time is short, I'll start quickly by showing the results that we obtained on the Selmark use case. So, and then I will be presenting the Timonier use case later. So this is a video that has been shot a few days ago in Selmark. Big thanks to all the partners who made this possible, who contributed, and especially to Ayman for hosting, my collaborators Davide and Fabio, and making it possible to integrate the grippers and to Selmark for hosting us. So this video shows an integration of two of our electroadhesive soft gripper in grasping one piece of textile using electroadhesion from a stacked pile. You can see that the gripper successfully lifts the fabric from the pile, only one piece, while leaving the other parts where they are. And during the demo, it was possible to demonstrate that the textile could be securely lifted, hold in place, and moved into the heat press. Then I'm sure Ayman will present more details about the whole system and the integration. I'll be focusing more about the grippers themselves, how they work and how they connect with all the other components. The working principle is the following. So it's based on a previous work that we did at EPFL and that was published in this IROS publication in 2021 with my colleagues Krishna and Herb from EPFL. The hard part of lifting grasping textiles from a pile, as you know, is separating the first textiles from the bottom ones. And the way we solve this problem with electroadhesion is that we position an electroadhesion pad on one corner. And electroadhesion, as you know, works like an on-off glue. So we turn on electricity and we can make the object in contact with the pad adhere to the electroadhesive pad. By doing this, we can lift a corner of the textile, and now we basically expose the bottom part without affecting the fabric that is underneath. At that point, we designed a simple closing finger that can now hold the textile using the bottom part that has been exposed thanks to the lifting using electroadhesion. And then once we hold in place with the moving finger, we can do whatever we want with the textile. Is now pinched and we can move it around. To obtain this, we had to redesign the kinematics of the gripper compared to the previous work that was done in DPFL. The new kinematics now make it possible to grasp from any point on the table and not only on the edges, because it doesn't interfere. There is no space taken by the finger up when the finger is open, and also it's quite compact and provides rotation and translation into different regions of the motion of the finger. You can see that when it's closing, it's almost translating, while when it's fully open, it's basically rotating back in place. The gripper is made with the following components. There is the electroadhesive skin here on top that goes in contact with the object. I'm not sure if you can see my pointer. Maybe I can use a laser pointer so that the audience can also see it from remotely. So the electroadhesion skin is over here. The closing finger is made with soft materials to avoid damaging the electroadhesion skin, as it's basically just a flat plate. Then there is a soft pillow. It's another soft structure that makes it possible to make it possible to have a good contact with the fabric without crushing the gripper, without having to use necessarily complex control. It gives some compliance so that even just simple position control makes it possible to have a good contact between the electroadhesive and the fabric. And then all the rest is pretty standard. It's just gears and motor to operate the finger. And there is a case underneath that contains all the electronics needed to operate electroadhesion and the motor. It took us quite a few iterations to get here. So those are a few of the previous versions of the paper that were developed. So we keep them because it's nice to take a look. So in 1 year we had to go through many prototypes to get to a final working shape. As you know, when you start with a new concept, it takes some time to get to a satisfactory result. Unexpectedly, we also had to modify the electroadhesive skins. You can see in the video on the left here, the one that were originally developed by EPFL. They worked well with single fabric, but we figured out after some testing that they could not hold stitched fabric well enough. So for this, we needed to also redesign it. Let's see if I can start the video. Okay. So here is an example of the old fabric that unfortunately can't hold on stitched fabric. Sorry, hold the electroadhesion pads that unfortunately cannot lift the stitched fabric. Stitched fabric is much more difficult than single fabric because you have just the fabric underneath that is pulling down the fabric that you are trying to lift. But we can't attach to it. We can't make adhesion because electroadhesion only works on surfaces that we are in contact with. So we modified the electroadhesive. We made many changes and we obtained a different design that you can see on the picture on the right that can apply quite a strong adhesion. Here is a hand example on a single fabric, but we can already see how it attaches very strongly to the fabric. In fact, it was able to hold stitched fabric very, very nicely. The main changes compared to the previous design are that now this pad can hold much higher voltage, as we have demonstrated in this publication on extreme mechanics letter. The adhesion, the zipping performance of the electroadhesion, so the ability to conform the pad and the object one to the other depends directly on the voltage more than on the electric field. So having a higher voltage generally, even with a thicker insulation, is beneficial in this case. So that's the direction we went to. We also improved the fabrication process. So many thanks here to EPFL that hosted us and supported us in redesigning and fabricating the new electroadhesives, and to my colleague Fabio Caruso, who also helped with the fabrication directly. So here is a few of the electroadhesion pads that we fabricated and tested and failed, and then we improved the design. This was also done in just a few months, but we felt it was very important for the success of the grasping tasks in this project, so we put a lot of effort in making this possible. And there is these 3 different versions. One is done with a PDMS film as the main dielectric, the second one with a mylar film, and the third one with a polyimide film. And then they are all insulated with PDMS on the back. To make this, to use these new pads that work now at higher voltages, we also had to redesign the electronics. So this was also done fast at Omnigrasp, and big thanks to my colleagues Fabio Gargano and Davide Grasso for their work on optimizing the electronics and the design. Also, always working against the clock. So here is the speed that we Omnigrasp higher voltage. I don't know if you know, electroadhesion goes with high voltage, low currents, and the voltage is a very important parameter for it to work. So here we are talking about for this also like renewable extremely low currents, actually just one of power actually uses. So it's not taking a lot of power, but we need to ramp up the voltage, so that's how our static works. And so we move from a prototype PCB that is now working quite nicely, everything integrated from control and high voltage electronics. So the user from the outside doesn't see high voltage. It's like as you have in many other, like in flashlights or cameras, you don't know that it's hundreds of volts. That's what happens with power to the battery. We follow the same concept here. Everything is self-contained, so that the user only sees an external 12-volt input can use it for communication. We had to engineer new connections so that they be robust and not interfere with the grasping. And finally, this electroadhesive with the improved pneumatics was able to lift most of the stitched textiles from Selma successfully. We also did studies showing that this is repeatable and can be done over many cycles. We improved the design to avoid the breaking of different components over tens of thousands of cycles. And the whole concept is to have a gripper that is compact, low cost, and self-contained. And see here, those are all the components required for the textile gripper. That's it. It can be shipped in a nice, it can be packaged. It weighs less than 1 kilogram with everything included, electronics and everything else. The interface is a simple 12-volt 1 amp plus USB and 1 amp speed current. Generally much less. It can be adaptable to any local town. We have a component here that we fabricate to attach it to different model of opticals. And as for the cost, so it's much cheaper than most high-end robotic hands. The electronics is the big chunk because we need some specialized high voltage components. We are working out to reduce this cost as well. The electronics is about 600 euros for this paper, while all the license components is less than what was estimated and can be squeezed down using large scale production optimization. So here is another videos, different textiles. Again, shoot last week. So it works with different textiles. Textiles about it. The paper could communicate with all the other components. Not everything was integrated in this demo. I will speak more about this, but finally use case facilities successfully. Blue textile will skip short. So let me move on the pouches now. For the pouches, flexible pouches, the structure of the gripper is different. We have most of the same electroadhesives, most of the same electronics, but the design of the gripper is slightly different. Here we show that we can successfully lift up. Here we show different pouches by Timonier. This is Harmony Glass Labs. Timonier, this is the demonstration of Labs facilities yet. This is based on facilities yet this week actually by Fabio. Thanks very much in advance, Fabio, for hosting us in your facilities for the demonstrations. How does this gripper work? How does this gripper work? So let me show by. So there is a central electroadhesive, there is a central lubricant, and 4 pillars that help. Questa è quella pesante. On a signal and using 12-volt input to make this possible. And it's silent, very low power. The concept on how it works is it's quite complicated. It combines the fact that the perimeter, by having only a central connection, is increasing with the force, and so with the detachment, and so the force is increasing and it gets to a stable configuration, combined with the fact that it also creates passive vacuum underneath the pillar where we apply the force. So this is all for the two use cases. As outlook, by the end of the merging project, we plan to deploy the grippers at Timonier this week, optimize the electronics to further reduce the cost and improve performance, having, if time allows, a professional build-up case and create the prototypes for the final demos if we decide that we will have other trials by the end of the month. This will be open to discussion. And then after merging, we hope to deploy those with partners and other interested customers to be able to use them. Big thanks to the whole OmniGlass team that made this possible with very hard work in short time, and to all the partners. Well, big thanks to Christine for coordinating this. I know how difficult it is also to deal with me, that I never answer emails. Sorry to everyone for my late replies, but it's really hard to combine the work with OmniGlass within merging and also my job at university. I'm doing my best, but our main goal was to deliver working grippers, and I think we accomplished that. I also take the opportunity of the floor 1 second to advertise that I received this year in year 6 starting grant, which makes me very happy. The project is called RoboFluid, and it's hosted at Politecnico di Bari. And I'm hiring. I have open positions. So if you know people that are interested to work on soft robotics, it's on a different topic. It's about using fluids to create innovative artificial muscles for wearable and soft robots. Just let me know or get in touch. I will be happy to have a chat. So I think that's most the end of the presentation for OmniGlass. I'll jump to the PFL one. Yes. Oh, if you have any questions. Yeah.
Yes, perhaps if you have some questions from the audience before we switch to the next presentation. It might be also presentation from people attending remotely. No questions? Okay. Just perhaps one question from my side. Yes. Do you have ideas regarding the exploitation plan? How do you want to develop your technologies, and what are the key markets you want to address now?
Yeah, merging offered two very useful parts, because both textile and flexible objects, as discussed in the proposal, are on high need, and I'm talking with more and more companies that are interested in technologies that can replace the labor that they don't have, because there is no people for this job. So many companies are struggling with it. So the plan now moving forward is to have those prototypes deployed as pilots in customer companies, and use those pilots as starting point for making a product on larger scale.
Please use the microphone so people come.
Thank you for your presentation. Sure. Good job. Yes, we saw application for Cellmark and Timonier, but not for VDL. Do you think you could have with your new electroadhesive gripper solution for fiberglass fabrics?
Okay, it's a good question. So we didn't go for that solution because in the initial test the PFL suggested that the object was not suitable to work with electroadhesion. The electroadhesive is stronger now. I can't really tell without testing. I have my doubts, because I think it's a form factor that is especially challenging for electroadhesion, but could be tested. And yeah, it's a good suggestion that at this point we could also check if fiberglass would work with it. Thanks.
Thank you. Good job for a few times.
Okay, thank you very much. I would suggest that we go for the next presentation just to be sure we keep on time.
Yeah, let's move. I think it's over there. I don't know if I have it here.
Yeah, it's already open.
It's already open. Okay.
It's somewhere on the computer. Ouais.
Je vais couper le micro là, j'ai mis celui-là.
Okay, so I'm also presenting in place of EPFL. No one could join from EPFL, unfortunately, today. So I'm happy to present the work on the stretchable capacity force sensor that was developed there. I was also part of this project when I was working as a scientist at EPFL, so I know the technology quite well. I was one of the people who developed it, and this was developed by myself with my colleagues, Bekir, who was the lead author, Krishna, Giulio Grasso, and Herbshe at the EPFL LMTS. The concept is to have a force sensor that is soft, so it can be bent, it can stretch, is robust, can be adapted to many surfaces, and can at the same time measure normal and shear force. So can have force measurements in two directions, and it's robust enough to be used in an industrial environment. That's a general common problem for capacitive sensors. They have many advantages, but the main issue is the fact that they are very sensitive to noise. So we wanted to tackle this problem by having a shielding, and by doing that, we figured out why most people that make soft sensors don't have shielding. The reason is that it's very hard to have a shielding on a capacitive soft sensor. So there was some scientific problem that we had to solve there to make it possible, that I will show. So the plot is showing the live recording from the sensor when of normal and shear force during the handling of different objects. You can see that the signal is quite clean and neat. We can distinguish the two channels very easily, and it can recognize different actions. But there is no intelligence now implemented, so it's just reading and watching at the plot. So why do we need soft sensors is because we like soft grippers. They are very effective in grasping many objects that are delicate, have different shapes. But if we want a sensor on a soft gripper, we need a soft sensor. Otherwise, the soft gripper is not soft anymore. The approach that we use to make this is to have a capacitive sensor with two capacitors made by 3 electrodes, and this can measure both normal and shear force because there is 2 capacitances between the central electrodes and the 2 sides electrodes, C1 and C2. If we squeeze the sensor, we are decreasing the thickness of the sensor. So by normal force, D decreases and both capacitances increase. While if we apply a shear force, then the area on one side decreases while the area on the other side increases. So by using the sum of the 2 capacitances, we can measure normal strain, and by measuring the difference between the two capacitances, we can have the shear strain. By calibrating the sensor, the shear and normal strain can be connected to shear and normal force. So as you know, unshielded capacitive sensors are problematic because they can pick up noise from the environment. They interact with the proximity of basically any object that goes inside their electric field. So we need some shielding. What is the problem is that if we have shielding with a soft sensor, so shielding is easy, right? We just cover everything with a conductor, and then we ground that conductor, and then we have a Faraday cage, and we have a shielding. That's easy. The problem with this kind of sensors, though, is that since the distance between the outside shielding and the electrode is changing, because everything is made with soft materials, then this creates some parasitic capacitance that will interfere with the reading of the main capacitance. We discovered this by error, basically. And we were surprised because we were compressing the sensor, we were expecting the capacitance to increase, while it was instead decreasing. And then we understood after some studies that the problem were these red capacitances here that are formed between the shielding and each electrode, and we can't avoid them. So the way we solved this was with the design and fabrication and materials. So we made the stiffness of the sensing layer, the one in light gray in the center, much softer, so with much more compliant than the stiffness of the external layers in dark gray that are still soft and deformable, but we have orders of magnitude of difference in compliance. By doing this, when we deform the sensor, the deformation in the sensing layer is orders of magnitude higher than the deformation in the external layers, and so the parasitic capacitance becomes not important. So the way this was done in practice was by creating the sensing layer using alternating chambers filled with air and with liquid metal as electrodes. So everything was highly compliant and could be stretched to a pretty large degree. We're talking about different tenths of percentage of stretching without damaging the electrode, the sensor. It's made with it's 1, 2, 3, 4, 5, 6, and 7 layers. So it's quite a complex construct, but at the end it ends up being a robust, self-contained structure. You can see a cross-section here on the right with the different channels. The main body is made with silicone, and then the channels are alternatively filled with liquid metal or left filled with air, so that they can easily compress and deform, because air is compressible while liquid metal and silicone are not. So the sensitivity for normal shear, for normal force, is 2.77 millinewton per femtofarad, and the shear force is 0.23 millinewton per femtofarad. So you can see that very small changes in capacitance make already detectable, measurable changes in force. And it can get a maximum load of 20 Newton, and the readout noise is just 0.09 femtofarads. So the sensitivity is pretty good, because we can measure plus minus 0.25 millinewton of normal force and 0.02 millinewton of shear force on a 20 Newton full scale. So it's quite impressive how much sensitivity it can have compared to the scale size of the sensor. And now for the shielding, so we demonstrated that the shielding actually makes a big difference. So we compare here two sensors, one with shielding and the other one identical but without shielding. And you can see that the red curve shows the response of the recording, the measurement of the unshielded sensor, while the blue one shows the shielded sensor. The shielded sensor only reacts when it's pressed on, so when there is some force applied, while the unshielded one picks up any proximity from the finger that goes nearby it. So it can't be used in any industrial environment unless you want a proximity sensor and an antenna to capture noise, which is not the case usually. We went for even a more extreme test. Since we wanted to use this nearby electroadhesion, we used a spark generation to create huge electromagnetic noise, and demonstrated then, well, you can see that unshielded sensor picks up all these electromagnetic hammering that we are doing on it with this high voltage spark generator. And this creates a huge noise, makes it impossible to use nearby something like electroadhesion that can have quite strong electric fields in the vicinity of its surface, while the shielded version is basically insensitive to those sparks. This is the blue line being shown right now. It doesn't pick up this noise thanks to the Faraday cage provided by the external conductor. Here's the sensor in use, attached to a robotic finger. We show that it can measure both shear and normal force on a gripper, actually, which is the goal that we had in mind, so the application. When we have normal force, both capacitances increase, while when we have shear force, one increases while the other one decreases, as mentioned before. And we decided to show that we can grasp a soft object, and we can sense when the object is grasped, and we can also sense when it's lifted and when it's rotated. By distinguishing the two different channels, we have enough information to measuring different situations during the handling of the object. So this can be used to feedback on whether the object was touched, whether it was lifted, and if we grasp it securely or there is some slippage. And then there is releasing, and we can also measure that. So the calibration process is done using a commercial load cell, and here we see after calibration what the agreement is between our soft sensor and the commercial load cell made of metal. Well, we can see that the two signals are very well matched one to the other. So this result was very encouraging, and this work, if you are interested, has been published in Nature Communications in 2022. It's called Shielded Soft Force Sensors by Bekirexor. Well, then the final part of the presentation is about arrays. So one sensor is good, but arrays are better for having, for example, slip detection. So My colleagues, I was not part of this work, my colleagues developed an array of sensors with the same design and demonstrated that they could measure also a wave of force moving on the sensor. The video shows that we can press arrays randomly and measure both normal and shear force with fast response and great sensitivity. And in this video, they show that it's possible to lift an object and, even better than before, measure the different situation where if it slips, for example, it can also be detected now using the arrays. Okay, that's the end. That's the end of it. So it was possible. We developed EPFL developed a soft sensor that can be used for with soft grippers for detecting grasping and slippage of different kinds of objects. And this is self-contained, robust, and insensitive, largely insensitive to noise. Thanks for listening. And if you have any questions, I'll be happy to answer.
Thank you very much for your presentation. So if we have time for one or two questions, please. Or perhaps from the audience. Questions?
Thank you again. It's also good work. And I just want to know if you have a commercialization plan for that already or not?
I can't answer extensively of that because that's EPFL work and IP. So I think it's more them that they should consider. I mean, they are considering this. Omniglass might have some interest, so we are talking with EPFL to understand if there is any part where we could use it, or I think they might have their own strategy that I'm not aware of, although unfortunately, so this has to be, it's a question to be addressed to have shared EPFL. They might have plans for it. It's from my side, technically, I can say it's a very robust and useful device, so it could be commercialized. I think many companies would be interested.
Manufacturing is easy or not?
Well, that's a point to improve. I think manufacturing is not easy at the moment. It's still very manually and time consuming. So there is some work to be done on modifying the manufacturing, like industrialization. So making the manufacturing more scalable. Yes, that's a good observation. Thank you. Yeah.
Other questions? On my side, I have one question. Okay. Because of the shielding, I assume that your material should work, your technology should work for conductive and non-conductive material, for grasping conductive and non-conductive material, isn't it? It's just mechanical in the end.
You mean the sensor?
Yep.
Well, yeah, I mean, you can get glass conductive and non-conductive. Yes, I mean, the shielding is itself a conductor which is grounded. It's like a Faraday cage, right? So every electromagnetic signal from the outside or voltage is just shorted to ground. So then the force sensing is done internally by the deformation of the material that changes the distance between the electrodes. So yes, it works with both conductive and non-conductive as far as we know.
You said that the range of sensitivity was around 20 Newton.
The range, the total range of usage of the sensor is 20 Newton. Yes.
Okay. How does it? Is it robust to overload? Basically, if you have higher forces, will it degrade the sensor, or will you just top the sensitivity?
You mean beyond 20 Newton?
Yeah.
I think beyond 20 Newton is not really usable. It's really soft and sensitive. So beyond 20 Newton, you just get to 100% of strain of the soft materials. So it's not meant to lifting things that are heavier than 2 kilos in this form factor. So if you want heavier, generally soft objects, it's difficult to have a soft, delicate object that is also very large and heavy. That's why generally when we design soft sensors or soft grippers, they are meant for objects that are not more than a few kilos. If you want to grasp larger objects, there is other options of commercial rigid sensors, or this can be also modified by making, for example, scaling it up, then you make your wall thicker, and then it can hold larger forces.
My question was to know whether or not there is a risk to break.
Oh yes, you can break it. Of course, if you apply 10 kilos to it, you likely break it, because you have channels filled with air and liquid inside. It's made of silicone, so yeah, of course you can break it if you hammer it hard enough.
Okay. Thank you.
Sure.
Thank you very much.
Sure.
I guess we will have the lunchtime to ask additional questions. Sure. And also we have the tutorials where we can deep dive into your technologies and having much more exchange. So I will leave the floor now for Ayman. So thank you very much, Vito, for your presentation, for your very nice presentation. Building blocks. That should be yours.
Yes.
Okay. So I need to, I guess, start. Just a moment, technical issues. So thank you. The floor is yours.
Hello everybody. In this presentation, we will talk about the precision blocks developed by Ayman during the merging project. We try to explain our approach and also how we resolve some problems during the integrations. Well, the first choice when we face a new challenge is choose the sensor. There are a lot of sensors. We have 3D sensors and also the 2D sensors. To make a choose, we need to take account the features. For example, if we will work in a scene with a lot of shadows and shines, we need to choose a high dynamic range. Or in this case, emerging project, we work with thickness products, in this case fabrics. Then we need a high precision. Then is the reason that we choose a Photoneo camera. You can see the Photoneo camera and also a 2D industrial camera. Well, once we have the hardware, we need to choose our software. There are a lot of algorithms in computer vision. For example, object detection. We need to find some objects of interest in an image. We have also semantic segmentation. We need to assign a label to a point or a pixel in a point cloud or image. Also, we have transformation and morphologic algorithms to just apply geometric equations to the image and find some points of interest. To resolve a problem, normally we need to combine some of these types of algorithms. Well, normal, the first step is the calibration of the sensors, but it's not always necessary to do that. Sometimes we just need to return a true or a false or make a call to an operator, then it's not necessary to do a calibration. It's only necessary when we need to share information between cameras, or we need also send a robot to a position, or something like that. There are two types of calibration: extrinsic, to correct the mistakes during the manufacturing process of the lens, or when we put a new lens on a camera, we need always recalibrate the system. And also extrinsic is just find the relative position of the sensor with the reference axis. In robotics, we have two typical configurations, A to hand and A in hand. Here, in the use case of Selmar, we have a problem because in the A in hand camera, we have the camera in the joint 3, then we only have 3 degrees of freedom, and we cannot do well calibration. Then the solution in this case, if you have this problem, is use external camera. You can calibrate that in a hand to eye or eye to hand configuration, and after that, just calibrate the camera in the robot with external camera like a stereo pair. Now, this is the challenge that we have in the project. One of them was people detection. Here, the objective is detect people and positioning in the real world. Because if there are a person close to the robot, they must reduce the velocity. Our approach: first, we use traditional computer vision, in this case to rectify the image to have a stereo pair, and after that we use artificial intelligence to detect people, and once we have the detection and the stereo pair, we just back project the points and we have the 3D point. But when we move to the real scenario, we have some problems because the rectified image has a hard distortion, as you can see here, and the neural network doesn't work. Solution here, the solution here is retrain the neural network, but this is not a good approach because every time that we change the position of the camera, we will need to retrain again. Then we just analyze again the problem, and we just change the order of the algorithms. We just use the neural network on the normal image, and after that, we just rectify the detections. And then the algorithm works, and in the same configuration is working in VDL and also working in Selmar. And here you can see the 3D representation of the detections. Next problem that we need to resolve is check the fabric position in the mold in VDL. In this case, the robots or the operators put the fabric on the mold. After that, the robot moves to a position and check if the fabric is well positioned. Well, here, as you are thinking, we use artificial intelligence, but in this case, a recurrent neural network to use semantic segmentation, and we obtain a max of the fabric, as you can see here. After that, we also again use traditional computer vision, and we analyze the max in these small regions, and we just use some algorithms to find distance between contours and also on, and we have a good accuracy in our lab. Problem here, again, when we move to the real scenario, the light was changed. As you can see, the difference between this image and the other image, the fabric looks very different. Light is the worst enemy for computer vision algorithms. Then here we need to retrain the neural network. As you can see, in this image, at the start we didn't detect anything, and after retraining in a fine-tune mode, it means just retrain the last layers of the neural network. Is faster. It's just in 1-2 hours we have again the algorithm working, and after that we apply the same algorithm and it's working also in VDL. Okay, another problem was detect if there are some fabrics on the edge of the mold, because if there are fabrics or another strange object or another foreign object, the mold cannot close. Here, we don't use artificial intelligence because we have some problems to do that. We don't have enough data for to train a network with all the fabrics or all the materials, and also maybe if an operator forgot some paper or anything object on the mold, it is take a error and we need to detect. Then we use the 3D camera because the edge of the mold can fit to a plane. And then we find the equation of the plane. And after that, we have the point of the origin of the camera, and we have the points of the neural network, of the point cloud on the fabric. Then we just apply geometric equations. It's just if there is a point between the plane equation and the origin of the camera, it means this is a strange point. If we have some points, in this case, we have a strange object. We don't classify the object, but we only need to send an alert to an operator there is an object on the mold. Well, next problem was in this case in Selmar, and as we see before, the fabric is put in the press, but sometimes has some wrinkles, and these wrinkles one can produce mistakes during the forming process. Then we need to detect and also send the robot some actions to stretch the fabric. How we do that? First, we check if the fabric has wrinkles. To do that, we calculate the normal points of the point cloud, and after that, we use the entropy of the normals like a metric. If the fabric is plain, the entropy tends to be 0 because it doesn't have information. And if the fabric has wrinkles, the entropy is high. Then, after that, we need to send the robot some actions to stretch the fabric. We train a neural network who evaluates or predicts how will be the entropy if we apply these operations. The neural network returns the actions and we send to the robot. Problem here, the data. We don't have access to the press. We don't have enough fabrics. We don't have the robots all the time to make trials. Then we use artificial data. We have a simulator and we use artificial data. And the results in this case are good also. Again, in Selmar, the first step is use the grippers to take the fabrics. Here we have the same problem that in the small, because there are a lot of different fabrics. Then we cannot use again artificial intelligence. If we have 1, 2, 3 types of fabrics, we use algorithm a semantic segmentation to do that, and we have the correct fabric. But in this case, we use again the same approach than the HMOL. We find again the plane of the table, and after that, we just find the fabric with the same equations. And also, again, we fit the points to a plane, because in this case, the major challenge is make a difference between the top fabric and the second fabric on the stack. After that, we apply traditional computer vision to find the lines, and then we just calculate the lines cross point, and we have the corners, and we just move some centimeters the points to send to the robots and the grasping points. And the last algorithm in Selmar was the quality control. We need to check if the procedure is okay. In this case, we replicate the operator's job. And we need to determine the depth of the brackets, and if in a correct site, we move the bra to a one point, and if it's incorrect, the bra needs move to the rubbish. And we use again geometrical operations first to find the plane, and after that we fit the points to a sphere, and we have the caps of the brass. After that, we just use geometrical operations, and is find the distance between each point to the plane, and the maximum distance is the depth. And in this case, we have a very good accuracy. Is less than millimeter. The time is, I think, is 0.5 seconds to process that. Okay, the conclusion is it's not always the most popular solution, the one to fit the problem, because here we have some problems to use artificial intelligence in some kind of algorithms because we don't have enough data, or also the GPUs is full because there are another artificial intelligence load in their memory, or we don't have enough frequency to use the best algorithms in the state of the art. Then sometimes it's better choice use traditional computer vision or combine some artificial intelligence and another type of computer vision. And that's it. And there are some questions.
Thank you very much, David, for your presentation. We have time for one question or two. In the meantime, I will switch to the next presentation, but please feel free to ask questions.
Then if they have questions outside, they can ask.
No questions? Thank you very much, David. I will invite Baptiste from CA for the next presentation. Thank you very much, David. CA, that's yours. Tac.
J'ai combien de temps à peu près?
Tu as 20 minutes. Alors attends, Virgin, ça tient celle-là ou pas?
Ça doit être celle-ci, je pense. Oui, c'est ça.
C'est bon. Alors, on va juste faire un essai. Attends, juste un petit instant.
Il y a
un petit problème.
Just a moment, we have a technical issue.
Ça partage pas la bonne fenêtre.
Yes, the floor is yours.
Thank you. Okay, I just wanted to check if I had a pointer. Hello everyone, my name is Baptiste Gradusov. I work at the Interactive Robotics Laboratory at CEA, and I'll present you a small synthesis of the work we've done in the Merging project. I won't be able to go into all the details, obviously, but feel free to go deeper with us afterwards during the poster session or this afternoon with the tutorials part. So the work package we worked on was mostly based on robot arm programming. And we had several building blocks that were developed in this work package. I'll focus on 3 of them. And the first one is about easy programming using skill-based programming by demonstration. The main objective of this building block is, in general terms, to accelerate robot programming and make it easy for people, especially non-specialists, non-roboticists, to use this system without too much learning curve. There are 2 main modules in this building block. There is a teaching by demonstration module and a skill concept. And the basic idea is to be able to teach gestures or various geometric primitives, such as points, trajectories, and so on, and use those gestures inside the skills in order to perform some actions with the robot. So basically, you have the robot that is able to perform an action with a skill onto the target. It can be a pouch, a piece of fabric in the case of the Merging project. And the skill, as I said, it uses the teach primitives. And there is also obviously some parameters to configure and adjust. And this can be done using various automatization and parameters optimization. So what is a skill? Well, one definition I could give is that a skill is some kind of a high-level robotic function that enables to reproduce operator capabilities which are specific to the task. For example, in the Merging project, in the timonier use case, we need to perform some pouch insertion. In other use cases, we need to move fabric and place it accurately for the process. And more generally, we can imagine some skills such as cutting pipes, screwing objects or doing object assemblies, polish surfaces, and so on. So the idea is to have functions that are understandable by the operator and which can be used easily by him in order to get assistance from the robot. The corresponding workflow is illustrated here. Basically, we have a library of skills with which we can define a sequence of actions. And once this sequence of actions is done, we need to teach the various geometric information that is needed for the skills. Afterwards, we configure the skills with other parameters such as the speed of execution and so on. and at the end you get the automatic execution of the sequence that has been defined earlier. I won't go into details about the skills framework, but one important information is that it's based on a robotics API abstraction that allows to implement skills which are hardware independent. So illustrated here, for example, if you have two different kinds of robots, one skill, once it's implemented, will be can be freely used either on the Franca Amica here or the UR10, and you don't have any hardware dependency. Then you have the teaching by demonstration part. Here the goal is to provide an easy and fast way to teach the various geometric information you need. On this video you have first experiments using modality of teaching which we call motion capture teleoperation. So basically we use a motion capture device which is an HTC Vive kit, and it's coupled to the robot in order to remote control it in real time and be able to learn the movements of the robot. On the left we have 4 different examples of teaching modalities. There is hand guiding, so basic cobotic use. Force feedback teleoperation, which is something that the laboratory has a lot of experience in. So we use a force remote control master arm in order to teleoperate the system. And motion capture can be used in teleoperation, as illustrated, or also by the direct teaching, where we use the remote control of the motion capture to teach directly points of interest onto the process. Each strategy has its advantages and drawbacks, so the choice depends on the situation, and our approach is to be able to provide those different modalities to be able to select the best one depending on the need. As a side note, we can teach different kinds of data and we can combine them. We can combine points in order to teach axes, planes, and frames of references. And those information can in turn be used in order to trigger some user assistances such as virtual guidance in order to make it easier to teach some complex movements. This video shows, let me, sorry, I pause it just for, I can't pause it. I can't launch it. Okay, so here we have an illustration of all those building blocks together. We're using first motion capture in order to teach the rail positioning of in the process. And in that case, since the hardware we are using for motion capture is not really precise, we needed to implement an algorithm of parameters optimization, which helps the robot to fine-tune the exact rail position by trial and error. This algorithm is really efficient. In about 15 to 20 trials, it converges towards the exact positioning of the rail, and it enables the robot to automatically and autonomously optimize this position for maximizing the insertion success rate. So once this automatic parameters optimization is done, the whole setup is able to cycle through the rail insertion. And here you can see that we have 2 robots involved. One UR10 on the left with a vacuum suction cup which grasps the pouches on the table. And the second robot, which is a Franca Amica, which grasps the pouch afterwards and does the insertion using dedicated gripper tips. So the second building block or module is on another topic, and it's focused on the co-manipulation of large flexible fabrics. The issue here, so it's basically related to the VDL use case to co-manipulate fabrics of up to 3 meters long in fiberglass. And the goal is to provide a convenient way to do this co-manipulation. The challenge here is that regular co-manipulation involves force interaction between the operator and the robot. We need to be able to transfer the range of forces and torques between the operator and the robot. And obviously, if you have a flexible object, you can't transfer any forces between the robot and the operator. One solution we worked on during this project was to use an instrumented glove, which will help to acquire the operator intention through different sensors, to be able to remote control the robot using a gesture recognition. And from another point of view, the goal was to have a low-cost solution. So there has been a huge amount of work regarding the industrial integration. Here you can have an overview of the first prototype here and the final version here. Basically, the glove uses multiple sensors, such as IMUs, flex sensors, and force sensor on the tip of some fingers. And all of those sensors working together allow to do some gestures recognition based mostly on the hand orientation. Here is some illustrations of the hands movement vocabulary that is used to remote control the robot. So basically, for example, I won't go through all of them, but just to give you an idea, if you rotate both your hands on the right, it says to the robot that you want to do some translation on the right. Same to go on the left. If you want to go forward, you turn your hands towards the robot in the same time, and so on. So with a library of a few gestures between the two hands, it's quite easy to handle all directions, both in translation and rotation, to remote control the robot. Here you can have a view. Will it start automatically? I'm not sure. I'm trying to start the video, but I don't know how to do it with the pointer on. Okay. I'm sorry, I'm having some issues with the video. Okay. So here you can see it was with the first prototype of the glove in action. You can see how it interacts with the robots. Here we have a lot of latency. It's mostly due to the robot we used. We used the Kobo Manip, which is a cobot that you will have the chance to see this afternoon for people at CEA. It's meant mostly for direct co-manipulation. It's not designed to move autonomously as a robot. So it's quite slow, but it has a large moving area. So it's convenient for large pieces of fabric co-manipulation. We did some previous experiments using a camera to assist the glove in order to get better precision. But those first experiments showed us that we could work without any camera. So at the end, we are able to do that kind of co-manipulation just using the gloves, a pair of gloves, as hardware. There is no calibration involved, and it's really easy to set up, and it's a low-cost solution. I move on because I don't have much time left. So we discussed the co-manipulation of large pieces of fabric, but there is also the issue of co-manipulation of large and fragile parts, such as the ones that are illustrated here. Still on the, let me put on the laser pointer. Still on the VDL use case. So it's large foam pieces. And so we have the same kind of issue. If we want to do co-manipulation with a back-drivable robot, it involves interaction forces between the robot and the operator. And of course, if these forces are too high, we will destroy the piece that we try to manipulate. So there is another difficulty, which is illustrated here, is that when you have a long piece of a long object that you want to co-manipulate, it's really difficult for the robot to understand whether you want to do a rotation around the robot wrist, or if you want to do a translation. Because the movement you do on your side, given the length of the object, doesn't allow to differentiate those two intents. And if you want to make sure that the robot understands, you need to apply a torque on your wrist in order to force the robot to move on its side. And of course, if you do that, even with a robot with good backdrivability capabilities, you'll have too much torque applied on the fabric, on the object, and you risk to break it. And of course, for the operator, also it's really complicated and difficult. So we need to minimize the efforts applied by the operator, and we need to minimize the stress applied to the object. And of course, we want to do it as easily as possible. We started with a background on the laboratory on virtual mechanisms, which are basically virtual guides. So imagine you have a trajectory illustrated here that you want to follow, that has been defined earlier. A virtual mechanism allows the robot to follow smoothly this trajectory with some compliance allowed thanks to a software emulated compliance that is implemented onto the robot motion control. What we did is that the robot, in that case, it follows the trajectory, but releasing totally freely the orientations. So basically, we ask the robot to follow the translations, but we let the rotations free in order to avoid any high forces applied to the object co-manipulated. And in order for the robot to follow the operator, there is a motion control that is added, where basically we measure the angle of error between the real position of the object and the orientation that is a target. And we generate a force control of the robot along the trajectory in order for the robot to follow the operator smoothly without having any force applied to the object. We have a couple of videos here that illustrate that. You can see on the left the co-manipulation between the operator and the robot. There is absolutely no force applied to the object itself, and so there is no risk of damaging it. And still, you can see that handling is really easy and natural, and it's quite easy to do some relatively fine positioning using this strategy. I'll try to show you the other video. Here it's an illustration using augmented reality, where you can see the path that is followed by the robot, and it shows how we can easily adapt the path of the robot in case of need. I can't go further into the video, I'm sorry. So here, if we have an obstacle that we want to avoid, it's quite easy to show the robot how to avoid the object, and once the new trajectory is learned, the virtual guide is updated, and afterwards the robot will autonomously avoid the object. So here the idea is to show that we can really easily adapt and define the required robot trajectory. So combined with the co-manipulation that you go on the left, you can see that it's really easy to set up and to put into motion in a new use case. You don't need a lot of programming effort in the beginning. Okay, I'll go quickly to the end because I'm out of time. What I showed you before was a strategy dedicated to quick transportation of parts. If we want to do some precise positioning, we developed another building block that combines the previous strategies with an added mean of teleoperation using here a space mouse in order to do some speed control of the robot to enable fine positioning of the robot. You have here a view of the result. It's not easy to see on the video, but it's really easy and natural to use for the operator. It allows for a combination of robotic movements on some directions and teleoperated movements on some other directions. That's basically it. If you have any questions, I'll be happy to answer. And if you want to go into further detail, we can discuss it afterwards.
Thank you very much for this nice presentation. Do you have questions from the audience? We have time for only one question because we are behind the schedule, but we have time for one question. Otherwise, still we will have time for during the lunch and also during the parallel sessions, tutorial parallel sessions, when we have two presentations from CA. So thank you very much again.
Thank you.
So I will invite you this for the next presentation, which is LMS1. Just for me. Time to
So I need to share it again. No. Okay. Could you please check if it works?
I need to switch.
Which one? Foundation? Appliqué? Yeah.
It's better for the remote users.
Duplicate perhaps. Does it work?
So far, yes.
Looks works. So thank you very much.
Thank you very much. So, hello everyone, also from my side. My name is Dionys Andronas. I'm a senior researcher at the Laboratory for Manufacturing Systems and Automation, and I am also the Emerging Technical Manager. Today, I'm going to present you our work for work cell control, digital twin, and also the supervision of the manipulation process of flexible materials. Let's have a general view of the challenges. When rigid materials are involved, it's quite more straightforward how you will be able to understand the recurrent position orientation, but with flexible materials involved, this is not the case. There are numerous degrees of freedom, and depending on the segmentation, the complexity can increase, and it's challenging on how robots can implicitly handle the intermediate, let me say, frames that we see here in this figure. So there is always the question on how robots can control a soft object's behavior. We can say that there are two schools. The first one is the implementation of empirical methodologies that rely on engineers' expertise. In this case, we can see closed-loop controllers or geometrical model controllers that are based on the trials and errors. So the engineer knows that there will be no collisions, there will be no fabric stress, or fragile object stress, and we are good to implement this solution in the manufacturing scenario. Whereas the second approach is to use methods that rely on digital scene reconstruction. So we want an accurate digital twin with a deformable object precisely represented, and this can take place either through sensor data or simulation modeling. So within merging, as LMS, we work on the modeling of the deformable object. And during the first phase of the project, there was a lot of activities on how we can balance the accuracy of the model, its performance, in terms of how many times per second we can have an accurate representation of the fabric, and also how we can make this model reconfigurable, because if we refer to the use case, for example, of VDL, there is a quite extensive bill of materials for the manipulated fabrics, and the handling scenarios are quite diverse. So we ended up in the development of the simulation model we see here in this figure. It uses the physics model, the mass print model from Provot. So the deformable object is reconstructed as a grid of masses interconnected through three types of spring. And one of our first activities was to deploy this simulation model as a ROS package that can be easily used for further activities. It was very important also at the beginning to define what are the grasping interfaces for replicating the diverse handling scenarios. On the left side, we see an implementation with interactive markers. These are these white spheres, which proved to be very useful during the design prototyping and also commissioning phases, so we were able to simulate handling inputs to the system. Whereas on the right side, we see two different implementations where we can have mass particles or arrays of particles being attached to robot links or human operator skeleton links. And this is very useful for runtime control. An important part now is how we would be able to dynamically reconfigure these grasping points. As we see here in these examples, we can easily, without effort, to add or remove grasping points or grasping interfaces. And this gives us the capability to, in runtime, to simulate grasping, releasing, ring grasping as well operations, and also in-hand manipulation. Another important part is our work on environment collisions. So as we see here in these three examples, the model can interact with a digital environment. And this proved to be very important, especially in the simulation phase, where we wanted to validate that the deformation of the object will not create significant problems or will not have huge collisions with the environment. And also it's very important during the runtime because we have quite accurate feedback for the distortion of the manipulated object. Speaking now of reconfigurability, it's worth noting that we have taken advantage of ROS capabilities, so all physics model and also reconstruction parameters can be accessed through our implemented plugins, and we can change modeling parameters without the need to reboot the system or recompile the code. And this is very important also for the final integration, because as mentioned before, when you have a series of fabrics, you need a model that you are able to easily adjust it to your needs. Now, when you have all these parameters, and also when you are relying on a model that imitates, let me say, the physics that are inside the object, it's not easy to find some parameters from bibliography or material science and say that, okay, I can use these parameters and proceed. So we have also worked as LMS in an automatized parameter calibration process. So we have an experimental robotic cell where the robot manipulates the fabrics into different positions. At the same time, we monitor the deformation of the physical fabric instance. And as we can see in this video, we have the filter point cloud from the physical sensors, and also we are changing the parameters and we are running the simulation until we find an optimal parameter set that we can say accurately describes the physical properties of the object. Another important part of our work is this, that is the one we are seeing now with the simulation of the diverse co-manipulation scenario, which take place with the use of a mask. This is a mask where, for example, the engineer can draw the shape of the manipulated fabric and also put some instances for the optimal grasping points for the robot arms and also the human operator. And these features here are very important. If we see the two examples on the left for the robot, at first we know where the robot and where the perception modules needs to check where is the grasp point, where the fabric is unfolded, and subsequently where is the actual grasping point located. Whereas for the placement, once we have the specifications from the end user or where to place the fabric on the mold, after hitting this target with the fabric centroid, we are certain on where we should transpose the robot arms towards the final placement of the object on the mold. At the same time, by using this information, we are also able to visualize to the operator where are the designated grasping points, and also, I will replay once again the video, use some extended reality buttons for confirming a grasping process. So the next thing, since we had a quite reliable model, was to extend it into model-based control. Very briefly, this model-based co-manipulation planner that was designed and implemented by LMS takes into consideration the operator handling inputs, as those are monitored by the perception system in the form of skeleton data, and most importantly, we use the human wrist coordinates. We also consider the fabric's distortion based on the simulation model in real time, and we are able to generate supportive robot trajectories that ensure that the robot responds to the operator handling inputs. We have no environment collisions. We do not have fabric overstress, and this is, let me say, the result of the optimization process that also considers the fabric parameters, some geometrical constraints, and also some specifications from the implemented manipulator. Through the years, we have a number of implementations with our model-based planner. In these two videos, we see some of our first trials using single arms. The perception sensor is mounted on the robot end effector, and here we can see how the operator is able to, without any gestures or interfaces, to seamlessly perform 4 degrees of freedom co-manipulation movement, having both rotation and translation together. And a comment here is that we can say that our system can be described as robot agnostic. We see here 2 robot variances, 2 different brands actually. And here we see also more custom manipulators that we are going to elaborate next with the description of the VDL use case. So here we have the co-manipulation of fabrics using a dual arm overhead manipulator that also has 2 additional degrees of freedom through the overhead portal. The model is more reconfigurable as well, the model-based planners. Here in this example, we use the same system. However, this time we use only 1 arm because we have a more narrow fabric. And let me say we are able to do so without any excessive effort. We just change some parameters and we are able to run the system. And at this point, we move on to the second part of our work as LMS, at least in the supervision part, which tries to deal with the complexity of the synchronization and orchestration when it comes to this kind of systems, because there are numerous software or hardware modules, and there is always a challenge how you are able, without too much effort, to supervise the runtime process and also how to monitor any issues. And when we want to deploy this kind of package that is able to perform this task, we want it to be intuitive, because there are also operators or engineers with less programming skills, and we wanted to expose, let me say, the functionalities through an intuitive environment. So the process is, let me say, can be described as the following one. The operator might come with a very brief chart on how the manufacturing process should look like, and this can be in the form of a Gantt chart or any other diagram. And then we translate it into an activity on arc diagram that then is translated into a JSON file that is stored in the workshop controller's database. So as mentioned before, our objective was to give to the operators and also the engineers the capacity to work on this process without significant programming skills. And for example, here in this video, we can see how you can, through a graphical user interface, to fill in activities into the database, write down messages or write down parameters and update the list of available activities. Then you can proceed to the creation of even more advanced abstraction layers. With drag and drop functionalities, you can find and place activities inside the diagram, so the operator can draw execution paths for normal operation or even response to errors, and start building even more complex activities. In this example, we can see the formulation of an even greater abstraction layer. Once again, we have the same drag and drop functionalities, so you are able to find instances from the database. However, you can also integrate other activities that have their own diagrams included. For example, here the purple building blocks have their own diagrams inside. Once you have this kind of activities, it is important to have an interface that allows you to edit these activities, or if you want to replicate them with some small changes. So as we can see here, we can delete, for example, a dependency, add new activities, and save the activity with a new name or replace the existing one. And once we have all these activities included in the database, we can just select one of them and proceed to runtime execution of it. And through intuitive colors, we are able to check what is the state. With silver, we have, for example, already completed activities, whereas with red, we have erroneous feedback, or in yellow, we see the activities that are currently ongoing. So, very briefly, because Kostas is also going to give you more details in the upcoming training session, this is our work in this topic. You can refer for more information to a recent keynote from Dr. Sotiris Makris, but also some publications for the distinct results of our work. Thank you very much, and I will be glad to answer any questions.
Again, we have time for one question.
Thanks for the talk. I have one question about the model for the fabric. So very nice how your model works and how you can simulate such a complex object. I've seen that, if I understood correctly, you use masses connected by springs, right? As far as I know, I'm not an expert in the field. I know that one of the most complex parts of modeling a fabric or a string is when you couple the bending motion with the stretching. So basically, when you start to stretch the fabric, because then you have a strong nonlinearity from having a very soft object, then stretches up and becomes a very hard object in stretching compared to bending.
Yeah.
I was wondering if your model is able to reproduce this and how this could be handled otherwise.
Okay. For objects that, let me say, can present greater elasticity, this is not a big issue, let me say, because we already have the infrastructure to measure this kind of bending or stretching within the fabric model. However, for example, here in this case where we are using fiberglass sheets, which is not very easily to stretch them, we have added one additional layer that tries, let me say, also using some geometrical constraints to avoid a little bit beforehand this kind of events. But of course, if you have environment collisions and we detect bending of the object, the first layers come on top and we have a corrective actions. But if you try to overextend, for example, the fabric, we will not reach to a point that the robot replicates this kind of movement, because we have one additional layer that says, okay, there is no need to overextend the fabric, keep it a little bit less than its original dimension. Because as mentioned before, at least with fiberglass, it's not easy to have very big deformations. But if we have something that's elastic, the first layer we had already fits quite well for this process.
Thank you.
Thank you very much again.
Thank you.
So it was the last presentation regarding the building blocks. Now it's time for us to go for the second session regarding evaluation of the managing technology for the 3 industrial cases. So we are. I will invite Eamon and Selmark to join and to go on the stage. We are a little bit behind the schedule, so if you don't mind to make it fast, I will just go to your presentation and give you the floor. Use case. And it's food packaging now. Selmark. Yeah. So again, I will need to share the screen. So that's your presentation. Okay, that's your presentation. I will just double check it works. Okay, that was the point. Okay,
thank you. Thanks. Good morning. I'm Diego Piñeiro, engineering manager of Selmar. For us, for Selmar, it's a pleasure participating in this event and works and develops an emerging project. I will go to present the use case of Selmar with Isidro Feynman, and the first part I will present. There are the context, the Selmar background. Selmar is an important Spanish brand from the textile sector. He's dedicated to the manufacture products of lingerie. Okay, we are in Vigo, in Galicia, in northwest of Spain, and we also we have factories in other countries, making dress in Portugal and Tunisia. The company was established in 1975. Currently, manufacture 5 product lines. These products, this family is the lingerie, handwear, swimwear, care, and tech. More or less 40 collections, 38 collections we launch per year. In small batches, we important number of the references, several and an important reference a year. It's important remark. Also, we have an important number of machines in the chains of value of Selmar, that the manipulation handling is an important weight in a process. Okay, this for is very important, the quality and product. We work with the best European suppliers, and we choose the importance and the high value technical fabrics, and we have certifications important. Stamps of the, for instance, Ecotex certificate important in the textile sector. This is the distribution. This is the market. We have a presence in 50 countries, with the invoicing about 20 million per year. And this is the distribution of the sales. It's important the national market. And the e-commerce is not important in this nowadays because the target is not a digital native, because it's growing up in these years. There are a process of Selmar. This is the chain of value. It's very important to remark this is chain of value, because in the textile companies nowadays there are a process outsourcing in other companies. In Selmar, all the process belongs to Selmar. Okay, and this is the well. First of all, the comments. The first, the design and pattern. We have 2 stores, the fabrics and the suppliers. We feeding the department of the cut. In cut, there are 2 ways: cut of the cups, of the brass, of the squares, and cut the other parts, the piece, a little piece of compose the bra. There are the brass is performing in fabric. This is the focus of the case. And when the output of the department of cut on the stores is composed to, is sent to the dressmaking, the works on the dressmaking in Tunisia, in Portugal, in Carabella fabric. This dressmaking is assembly, making a bra, a skip, and makes the quality control in the final of the line. Returns to warehouse in Selmar, in Vigo, and the quality control, and this is the store that he makes the picking, packing, and expedition with the client. The use case is focusing. Is not a video. The use case is focusing in the thermoforming press. This is important because we have this is in the video, we have a stock, the squares 20% become into a perter from brass cup. This has a press, this is thermoforming press, these are two press, and a worker fits the two thermoforming. And this is a critical place, the fabric ensure the position. It's important. This is okay. This is make the thermoforming bra, and there are the quality control after the thermoforming. Okay. The challenge of the project was we face with the following problems, because ergonomic using is for the humans. The operator is very important. Faulty parts due to human errors. The high cycle is a stable high cycle time, a low production rate. And the challenge of the automation is the flexible parts involved in the process, difficulties in the manipulation, and the quality inspector requires. And to continue with 05 men we'll follow with the presentation.
Thank you, Diego. Yes, after Diego presents us the Selmar company, I'm going to present you on next slides the technical developments of the merging project, more focused on the Selmar use case, where I was working on for last month. First of all, I would like to say that this is a research and innovation action project where we explored the feasibility of a new turnkey robotic solution, merging the different developed technologies from the different project partners, from a simulated environment to a relevant controlled environment at the Selmar workshop. If we refer to the technology readiness levels, we started from the TRL 3.4 proof of concept in lab environment, and we evolved to the TRL 6 at the end of the project with the evaluation of in a relevant scenario at Selmar workshop. We started the project with the background knowledge from the different partners of the project. The first stage was to define the end user specifications and requirements. With this information, we use it as a roadmap to develop and to integrate all these technologies at Selmar use case. And finally, we were able to finalize this project in the last stage with a robotic cell for the Selmar use case. On this slide, I wanted to represent the different technology regarding the Selmar use case.
which were integrated on the robotic cell, besides as well all the representative hardware installed on it as well. About the hardware, we use 2 collaborative robots UR10, 1 PC server with Ubuntu and ROS framework installed on it, a few vision cameras to perceive the parts and the environment as well, a remote controller as well with another additional hardware to program easily the robots. And finally, the grippers we use to grasping gently the fabrics at Selmark. Furthermore, we have several software models we have developed to manage all the tasks to get a robotic cell with the ability to handle the fabrics at Selmark workshop. These models are the next ones. The first one, for example, on the left is the stack localization model. Is the responsible for locating in the precise points on the stack top of the fabric for the grippers to grasp it. The other model, for example, is the deepness quality model. Is the responsible for measuring the deepness of the bra caps on the fabrics on each fabric thermoformer. Another model is the wrinkle removal model, which is the responsible for the detecting and removal, if necessary, the wrinkles which on the fabric when we laid onto the press before the thermoforming process. And if there are wrinkles, this model gives us the points for the grippers to grasp and remove the wrinkles from the fabric. More models. One of them is the human perception model, the responsible for detecting the people working besides the robots, to change, for example, the robot movements velocity, or to stop them if necessary, if the humans are very close to the robots working. Another model here is not good. Is not expired. Is the mock-up, as I understand, Baptiste. Is not expired. Is the mock-up teleoperation model? Sorry. For programming the robot easily with a dedicated hardware, is a which is a remote controller of the self. And there is as well the gripper model, the responsible for the activating or deactivating the grasping or the performance of the grippers when handling the fabrics. And finally, we have the last model, the controller model, which is the responsible for intercommunicate all of the other models between them, and to synchronize all of them to finally work all of them together orchestrated, right? And on this slide, I wanted to show you the relationship of this all software and hardware. We have the PC server with Ubuntu and ROS, and all of the software models inside of this working inside of this PC server. There is one model in the middle, which is the cell controller, which orchestrates all of them and intercommunicates with all of them. And these software models are finally connected and communicating with every dedicated hardware, depending on each model. For example, the perception stack on the quality perception of the vehicles are working with the Photoneo or IDS cameras were installed onto the robot. The human perception model is working with 2 IDS cameras, fixed cameras on the surroundings of the robotic cell. About the gripper control, it works with the 2 grippers installed onto the flange of the robot. And finally, the robot programming, which communicates with one controller, remote controller, and the tracker, which are hardware from the HTC Vive Pro 2, and as well with the 2 UR10 robots. To finalize this presentation, I would like to say some conclusions. Finally, all the technologies on this demonstrator were integrated and working perfectly well. Some of them were correctly deployed finally. The robotic cell prototype, as I said before, achieved the TRL6. It's a prototype. Some improvements required to optimize the cell performance. For example, the robot movements. All the time we need to move the fabric from the stack to the final stack after the quality checking, after the performing, and after the thermo process forming. Were very long compared with the operator. So this is something that we should improve more in the future. I would like as well to remark that some fabric types didn't work very well with some modules. For example, with the perception from the stack, some of the fabrics couldn't was perceived by the stack module correctly. And for example, as well, we had problems with the gripper, with the grasping module, because sometimes some kinds of fabrics couldn't be grasped with the grippers. And I don't know why, maybe because of the different features of these fabrics, or maybe because of the ink as well. Sometimes the ink is important in this for these fabrics. And I would like to say that we should improve as well the final reliability of the overall demonstrator. And this is all of this presentation. Yes, I don't know if we have more time to show the final video of the demonstrator. How do you do that? This workshop merging.
Just I will step in.
Sorry.
Because there's one software that works.
For the comparison with the video.
Yeah. To compare the robot working against the human operator. Yeah, is it. Thank you, Romain.
It's 2 minutes. It will be okay.
All right. Thank you. Just to show you, this is the video. This is the first position when the robot performs a picture from the stack to perceive the precise points to grasping it with the grippers. Then the robot laid onto the press the fabric. Now is checking if there are wrinkles before thermoforming the process, and in this case wasn't very big. The wrinkles, as usual, is really very difficult to find wrinkles when we handle the fabrics with the robots. Now the robots take it from the press, put the fabric onto the quality base to check if the deepness is enough and comply the quality. in different points, the robot, when in the different points, the robot with the cameras on the top takes the pictures to check. And now the robot is blowing on the fabric to put it in the good position of the bra caps to avoid any wrinkle and to measure correctly the deepness. And in this case, like the bra caps were correctly, it lay the fabric onto the table. And this is what we achieve with this project at Cellmark use case. That's all. If you have any other question you would like to ask, yeah.
I wanted to ask, what is the purpose of human perception in this robotics application?
Yes, it's a model. We could say that it was about safety, but it's not. It's about the safety. It's not rated safety, this kind of device. So this is a model we use it to work with the robots when the human workers have to work besides or with the robots very close to them. When the robots are working with velocity not too much high and in a reduced speed mode. If we would like to work with robots in higher speeds, in that case, we should employ a rated safety device, like, for example, the laser scanners. Is the difference what we found about these two kinds of working with our safety-rated devices or the human perception model, for example. This is my answer. I don't know. Yes, because as Diego says,
in the place of the thermoforming, there are different sprints and different people working. This is the combination is possible fighting the human and the works. And that this place is very small and very crowded. The people.
Yeah. This is. I don't know.
Any other question? Okay, thank you very much, guys.
Okay,
I will invite you, Benjamin, to comment and to present your work on the food packaging application.
Je vais le corriger. Tu fais tout l'écran, puis tu fais écran 2. Okay.
So, hello everyone, I'm Benjamin Graf from Timonier. I'm a technical coordinator of Design Office. So, I'm here to talk about the evolution of emerging technology with the food packaging use case. So, first of all, I'm going to introduce Timonier. We are SMEs of 86 employees located in Lyon, in France. Our main expertise is in custom-made machines, and we made 75% of our exports. That's on all continents. For example, currently we got some machines that are going to go to Algeria, Canada, and India in the same time in the workshop. So actually, we have like more than 300 machines in all around the world, and one of our main proud is the fact that we invented the Doigt Pack, which is the stand-up pouches. So from the Timonier is an historical company which invented the sewing machine in 1830, and then it goes with the plastic films with the invention of the berlingot in PVC, and that's why now we are specialists in plastic sealing, dosing solution, and high-speed film handling. So why the merging projects? It was all a matter of this kind of machine, which is called SF. So this machine has some input, some preformed pouches, which are inserted into a rail. Then the machine will fill the product into the pouch, and then we will screw some caps on the pouches. So the output of this machine will be a full-filled pouch with caps on it, with screwed caps on it. So as you can see, the process with the filling process, and then we are going to screw it, and the pouch will go out of the conveyor. So, yeah, you can see the screwing process on this one. And then the pouches are going out, and that's another machine that will go. So with those kind of machine, some clients had some needs because those kind of machines need an operator to prepare the inputs of the machine. As you can see on this video, the pouches are delivered by in like this in the cardboard, and the operator have to insert the pouches into the rail. So that's very boring task, which need to be well done, because they have to eventually flip the pouch if it's on front or rear side. And so we tried to automate it, but it was too difficult for us because it's due to some fact that there are some soft pouches manipulation, so some unpredictable way that the pouches go in, and the recognition of the front or rear side of the pouches, and there was the difficulty of the insertion, because we only have like 0.5 millimeters to insert the pouch into the rail, and we have a lot of pouch variety for that. So yeah, and as you can see, there is the processes of the inserting rail that we automate, but it's only a matter of buffer stock. So the operator still has the work to insert into the rail. So we have a lot of pouch variety. For the merging project, we decided to put one sample like those, because it represents a lot of example that we can see on our client example. And we mainly focusing on the first one, which is the PET PE complex. So our initial objective by participating to a merging project was the fact that the operators will focus on higher added value mission, so it will be less penability and more cost effective, because it will focus on maintenance stuff and not on insertion pouches into the rail. That will decrease the risk of MSD, so musculoskeletal disorder, and it will allow our machine to run like for 24 hour on 24 hour, so that's more cost effective. And on another end, it permits us to make a first step into a 4.0 industry with robotic manipulation in our SMEs. So for the merging approach, we get started with the difficulty analysis. So as I said before, it was difficult to have precise location and grasping of the pouch on the flat surface, because it's really easy to have something with a suction cup, but not with a two-finger gripper. The fact that insert the pouch into the rail is very difficult due to the precision constraint, because as I said before, to put the pouch into the rail, we only have like 0.5 millimeter of mechanical game. And one other big point that it was forbidden to handle the plastic tip by the tip because they're also food compliant that we have to respect. So that's why there are some choices that have been done with a two robot setup, one in order to grasp, one in order to insert, because it was too difficult to handle both of them with only one robot. And for the pouch grasping, we are making our first experiments with the vacuum suction cup, and then OmniGrasp will come into a factory in order to make some tests with the OmniGrasp prototype. And for the insertion pouch, we have a standard gripper with CEA gripper. So for the blocks that we are using in our test bed on our prototype, there is first of all the pouch localization made by Ayman, and the skills from CEA, and it will be the OmniGrasp gripper, and all of them is orchestrated by our work cell controller done by LMS. So I think I can skip it because Baptiste told us about it. So the integration at Timonier facilities, I will skip it too. And first of all, we made an hardware test bench with, as you can see in first, the insertion rail. Yeah, that will be easier. So we got the insertion rail that is over there, the camera from IDS that is over there, and those two robots, one from Omron, the other one is the Universal UR10E. And the UR10E is with CA patented gripper and robotic U gripper. And this one is with suction cup for now, and will be with the OmniGrasp gripper by the end of the week. So we can see the video of everything working on. So I would just so that's the Ubuntu PC that we have at our factory. We can see each building blocks working on, like this one is for the Omron robot, this one is for the UR10E, this one is for the camera, this one will orchestrate everything, and those are for the LMS work cell controller. So once everything is running, we can run it from the work cell controller made by LMS with a full cycle. So Now the IDS camera will detect the position of the pouches. Then the robot will go to grasp it and then present it to the next robot. Then there is a move in order to assure that the pouch is aligned with the gripper, and then with a mechanical position we can insert the pouch into the rail. So the arm run goes for another pouches. Yeah. So to conclude, first of all, about the process feasibility, it works. So that's cool. We have a functional prototype. For the robustness performance, that's all a matter of estimated data, because we had not enough time to test it more in details. So for now, I think we can tell that we have a success of insertion that of 80%. It's mainly due to some problem with the detection. Sometimes the pouches will not be located at the good position because of some reflex on it. So that's all for the robustness and for the speed for performance. Our full process for now is like 24 seconds per pouch. I think our goal is about 15 or 30 pouch per minute. I think that 15 is easily reachable by playing with the robot speed optimization. But I think that 30 pouches could be possible if we having a vision system that is able to detect them in bulk. And from industrial perspective, I think that we have some work to do. That, as you said before, we are in Tiriel 6, I think, and so we have a lot of things to do in order to optimize the cycle and the speed process. And if we're able to do that, I think we could manage to sell those kind of machines quite easily. So that's all for me. If you have any questions, do not hesitate.
Questions? Any question? Could be also a question from the people attending remotely. Okay, no questions. So thank you very much, Benjamin. Last presentation this morning would be you, Volkan, with Genesis regarding VDL. So I will load your presentation and the floor is yours. I will just need to, again, to share screen. Could you please check? Right.
Presentation, madam. Should work.
Okay.
It's good. Thank you. The floor is yours.
Okay, thank you. For those who joined us just now, I'm Dionys Andronas. I'm a senior researcher at the Laboratory for Manufacturing Systems and Automation, and I'm also the Merging's technical manager. And together with Volkan Dileci, who is a factory engineer and manager at VDL Fibertech Industries, we're going to present you our results in the large composite manufacturing use case. Before we delve into the details of the overall solution and the enabling technologies, it would be beneficial if we have some insight about the manufacturing process. So, Volkan, share us a few details from your shop floor.
Yeah, as you can see here on the picture, we have a big part made up of composites. We use it as a product for heavy transport, public transport. So because of the size, it's very, it's known that the composites are the most of the costs are labor, because it's manual layout. So it's known that the cost has to be reduced from the labor. And in this case, the size of the product, it takes with it that is very poor accessibility to put the fibers or the foam cores inside the mold. And the repetition of the operators is also very depending of each operator, each skilled operator, what you have there, and especially also the exposure regarding the small fibers. It's always itching. So these are the very challenging parts or the motivation in this case to implement some automated solution for it. Then as we continue, we need also a lot of skilled operators due to the process complexity, because it's all fibers cut it in a certain shape. It has to be fit exactly in the cavities of the mold, etc. And especially also the parts, because the end product is huge. We have also big textiles or technical fabrics. Here you can see some big parts. On the left picture, they are manipulating with two operators the foam core with glass fiber to put it in the mold. And on the right top corner, do you see on the picture that the people are getting on the mold to apply some force on the fabrics and put it in a certain way or a shape. I think, let me see. Dionys, you can take the technical part.
Okay, thanks, Volkan. So within merging, we wanted to improve, as mentioned, the operator well-being and also the quality and the efficiency of the whole process. So as LMS and as a pilot driver for this case, we led the engineering of this overall solution, which is responsible for the transferring of the composite layups from the material storage on the mold, and then we proceed with the layup operation. The first step of the whole operation was to design a custom dual arm manipulator that is able, based on the specification of this use case, cover the majority of the handling operations. However, as mentioned before, when you have rigid objects, it's more easy to describe their position and orientation using just a single reference frame. Whereas when non-rigid materials are involved, the number of degrees of freedom rises, and also the complexity rises as well. So for this purpose, we need state-of-the-art software and hardware modules to be able to control with high proficiency the material distortion. In this regard, the consortium has worked on the development of a number of enabling technologies which cover many aspects and upgrade significantly the capabilities of the manipulator that we see here in this figure, and they involve a number of perception, orchestration or handling modules, as well as a number of controlling modules as well. At this point, we will go through all the implemented enabling technologies one by one. The first thing was to provide the necessary handling capabilities to the manipulator. So LMS designed a multi-tool end effector, which is able, without excessive tool changes, to handle all composite materials and also perform layup operations on different mold cavities. Next, we have a series of perception modules. On the left side, we see a module by LMS for 2D vision grasping point detection, which is used prior grasping, where an on-robot camera detects any misplacement of the fabric by the operator and updates the position of the actual fabric in the digital twin. Whereas on the right image, we have the quality assurance module by IMAN, which detects if the fabrics have been placed correctly inside the mold and triggers, if needed, corrective actions. We have also perception modules for human tracking, and those, as we see here on the left, and the two left examples by LMS, are used for direct human system interaction and also for human-robot collaboration. Whereas on the right side, we have for the fully automated operations, the speed and separation monitoring module by IMAN. We move on now with another crucial module which deals with providing to the manipulator the necessary cognition for understanding how the manipulated object is deformed. As mentioned before, LMS has worked on the implementation of a reconstruction model that simulates the deformation of the fabric during the diverse handling scenario and can be easily be reconfigured. With these modules now in our possession, the next thing was to implement control algorithms. In this first example, we have the model-based human-robot co-manipulation controller by LMS, which is an extension of the previous reconstruction model that, as discussed in the previous presentation, considers the handling inputs of the operator and at the same time considers also the deformation of the fabric towards the planning of supportive robot actions. We see for this use case two examples that involve dual arm or single arm co-manipulation and also make use of the 2 degrees of freedom that the portal brings to the system in order to cover the material transferring in this vast area footprint. Next, we have two control modules by CA. On the left side, we see the controller for the manipulation of fabrics, which is based on the inputs provided by the wearable gloves that Baptiste presented before. And on the right side, we have a closed-loop control framework for the manipulation of fragile objects, which in our case are the foam blocks, and it's based on impedance control, but there is also a 3D space mouse for high precision positioning of the objects inside the mold. Now, as presented once again, when you have all these hardware and software modules, it becomes evident that the orchestration and the supervision of the whole process is quite challenging. And for this reason, LMS developed an intuitive orchestration package, which is called the Workzone Controller, with the objectives of intuitive activity creation, intuitive manual scheduling, and also monitoring and control of the runtime process. Finally, since operator remains in the loop, we wanted to deliver a human-centric system. And for this reason, as LMS, we implemented two extended reality applications that take advantage of the accurate digital twin that we have and also the real-time image feeds. And as we see here in these recordings, we can provide in a highly intuitive manner information and support content on what's the grasping point topology. And then we can also see here how the operator can inform the system through extended reality buttons that the fabric is grasped in order to trigger the co-manipulation process. And at this point, we can also see through augmented reality content how where the fabric should be guided and placed within the mold. And at this point, since we are now more or less aware for the enabling technologies, we have a video that describes how all these modules work together. So the process starts with the extended reality button. Once the operator grasps as well the fabric, the model-based co-manipulation planner starts. And here we see a dual arm co-manipulation scenario. We see in parallel the digital twin and also the operator support window. Here, without any tool changes, we are able to lay up the fabric on the mold. The same model-based planner is used also for fully automated operations. Here is an example of a very tricky part, let me say, but there is also another example with a more simple geometry. Here we see through the mask where the fabric should be placed. Once again, with the same tools, we lay up the material inside the mold. The same tool also is used for foam block material transfer using needle grippers. But there is also an additional example where the same tool is using a parallel finger gripper, and in collaboration with the second arm, we are able to perform dual arm manipulation of foam blocks. Once again, we put more materials inside the mold. In parallel, we can see the orchestration package synchronizing the process. And here we see alternative handling scenario that take full advantage of the robot capabilities. At this point, we have two additional big fabrics that will be guided inside the mold. Here we see also the grasping point detection module in action. So the fabric is shifted inside the digital twin, and the grippers grasp the fabric from the designated grasping points. And now we see that once the operator hits with the fabric centroid the targeted position, the arms will be interpolated to the releasing points as those were declared inside the mask. Once again, same tool, no tool changes, and we are able to apply forces inside the mold to stretch the materials. And finally, we have once again the vision system. Once we detect where the actual fabric is, we have the initiation of the co-manipulation process with the extended reality buttons. And for this example, we see that we are using just one single arm instead of two, since we have fabrics that of less width. And we have a couple of additional examples here. So once again, the operator hits with the centroid and the robot releases the fabric. Here we see the foam co-manipulation module by CA in action. At the same time, we can see how the process is also orchestrated by the work cell controller. And we can see also here how the user with the 3D mouse can accurately fine-tune the position of the materials in the mold. In this example, we see the glove-based controller by CA. So with the integrated buttons, we give a feedback that the fabric is grasped, and then we start the co-manipulation process. And at this point, we can see the manipulator transferring the fabric to the final position, and we can guide the robot to the release spot with high precision. Here is an example of how the quality assurance module by Amen works. We had a testing with the integrated sensor on the gripper. Now the robot will come back and will check if the fabric is properly placed there. And if it's okay, it then proceeds to the next point. We see here it's not properly placed, so the operator is informed through the tablet interface that the corrective action needs to take place. And here is also an example of how the speed and separation module by IMENT works during the fully automated operations. So currently, as we saw, the system is integrated at VTL facilities. We have completed our validation campaign, let me say, and we have performed multiple tests with the system, and also we involved human operators. We are now in the process where we analyze the results, and we are confident to say that we achieved the use case requirements. We have improved ergonomics, we have improved efficiency. And the reason is that currently with the implementation of the manipulator, operators, it's not necessary to climb on top of the mold to reach the areas with less accessibility. We can have parallel task execution in some cases where the manipulator can independently transfer materials inside the mold. And there is also a reduction in the worker full-time equivalency and also the repeatability of the process. These remarks can also be validated by the end user and also the operators, who expressed that ergonomics is significantly improved, and the system is now interesting to work with. The process is now more interesting than before. And the end users also see that there is potential for improving quality, because now we have the repeatability of the robots involved, and also we have a high-level orchestration system that continuously supervises the process, also with the use of the quality assurance modules. Some general remarks before we conclude this presentation is that non-rigid product manufacturing still presents challenges, and despite our advances, we should continue our research activities on further improving the maturity of this module. As researchers, and also the European Commission should proceed with the new goals that will further improve this kind of operations. We discussed a lot about AI. An observation, at least from my side, is that machine learning at this point could improve the results that we saw, but it cannot fully replace yet. The reason is that we have a large portfolio of products. The bill of materials is quite extensive, so training needs a lot of time. But if we skip this part, we can say that the efficiency of the process will be significantly increased, because robots will cooperate in a proactive instead of reactive manner with the operators. Finally, what we found out during the training phase with the operator is that training is a very important part. Operators still need to learn new skills, and this highlights the need for new training services and new training methods. Finally, an outlook on what industry needs. Industry needs abstracted plug-and-play, let me say, functionalities, where operators inside the factory will be able to in-house implement and also maintain this kind of modules. And these modules also need to be secure and certified. And this brings a responsibility, I would say, to the research community to support the standardization committees for keeping up with the recent advances. So that's all from my side. If you want more information about the enabling technologies, you can refer also to these publications by the partners. Thank you very much for your questions.
So I guess there will be some questions from the audience regarding this nice presentation.
I suppose everything was clear.
Sure, but anyway, there will be plenty of time for sharing, asking questions during the lunch. The lunch that will start now. We will have some time for the lunch, but not only the lunch, also the posters. We have a poster session and afterwards we will have a presentation, a visit of 3 labs here at CEA. So please have a look at your badge. There is a number 1, number 2, and number 3. This is the number of your group, just to have a kind of balance between the number of persons in the group. So group number 1 will be with Jan. I don't know, Jan, if Jan is in the room. So group number 1 will be with Jan. Group number 2 will be with Julie. So Julie, you are here. And group number 3 will be with Frédéric. So the visit of the labs will start at 1:35. 45? Okay, 1:45. And the room table is at 2:45, isn't it? This is okay. So thank you very much, everyone, for people attending the meeting remotely. So let's meet at 2:45 for the room table with industrial partners. So I would like to thank all the presenters for this morning for the very nice presentation. Thank you very much. And the lunch is, and the poster for those who don't know yet, everything is in the other room over there. Je sais pas comment rendre les choses plus simples. Je sais pas, écoute, pour aujourd'hui, je pense que on va faire comme ça. Ouais, il y a un petit peu de flottement. Je sais que je sais pas plus pour aujourd'hui, comme ça, de toute façon. So that will be webcasted.
I am visible. Animate.
So, okay, Benjamin, please. Yes. And cast also.
Hello everyone. We are back online, and this time in the roundtable session on how technology can help robotizing of materials manipulation tasks in the industry. My name is Alexis Patli. I'm a technical manager at IBC France, and to my right, I have Volkan Village Chief, factory technical manager from Brigade Factory, Netherlands. And to his right, we have Diego Pinheiro, Director of Innovation, Telemark, based in Vigo, Spain. And to his right, we have Rafael Fagoti, the project manager of Optimum, who manufactures the machines for robotics. And then we have Andreas Neri, who's the technical manager at Casper, a software clusters in company-based Athens. And finally, we have Benjamin Kra, technical manager at Deformable, who manufactures machines of automated machines for logistics. So, thank you all for participating in this, for accepting part of this roundtable. I'm going to start with the first question, just for maybe to the end users first. In your activities, how did the technologies of merging project push the boundaries of your daily operations? Has there been significant influence in the daily usage in your factory site? Has there been some improvements in the working environment of your employees?
Thank you, Albrecht. Yeah, regarding your question, of course, it had some impact on the industry. We saw some light end of the tunnel in this case. We approached in the past some suppliers to find some solution for the layout, especially. It's a very common problem in industrial environments. And we saw, of course, improvement of a lot of building blocks, for example, the ergonomics. We saw improvement by the operators. They didn't have to step on the mold, which brings damages with this. And we also we had also some positive regarding the repeatability. That's also a huge step in our industry. Now it's operator depending. You get different kind of layout or different kind of working. Now the operator is forced to use the same system and same way to apply the fabrics. And the important one we see it's familiar that the operators or the people on the working floor, they're not easily adapting to a system, to a new system. The change in the humans or in operators is very different. It's a cultural change, so it's very hard to adapt people in industrial environment with that kind of application. Now we see also people adapting very fast because it's easy to use. It's fun to use. It's nice technological advanced some playground. I think that's the most important of my part. And maybe the other end users can use that.
Thanks. So, for us, it's very important. Very important. The collaboration with the supplier, for instance, is important that the Selmar is all the every day working in a context very close, because with the space of the mind, they open new technologies is very important for us. And it's important for us that the system of the quality control not depends on the ability of the people, not depends on the ability of the community, because it's necessary. It is, for me, it's very important the cost of opportunity. If my workers is working in other operation with the value added, the solution of the money is replaced or coupled with the solution on this space. For us, it's interesting, and there are new challenges, new opportunities in logistics, in other processes. I'm explaining the for us, we have many processes, diverse processes with hand workers. It's interesting. This collaboration with the codes is more important for better vehicles.
For my point of view, it's a little bit different because we are not the real end user, but our client will be. So that's a little bit different from you in the case that they are directly the operators on the machine. We do not know how the operators on our machine works. So it's only a kind of communication with our client that they told us that there was a lack of time due to the input in our machine. So they asked us if we can provide a solution. So that's why emerging is beneficial. It's because we can provide some solutions, some innovative solution to different type of client and try to reduce MSD.
Thank you. Well, I see that it has definitely improved the life of the workers, but as a solution that has to be implemented within the premises, maybe what would be the considerations for integrating these kind of solutions in the existing workflow of an industry or of a shop floor which is continuously in production, and how do you ensure that this workflow is not disturbed when we implement these kind of new solutions? Maybe this, and how do you ensure when these solutions are implemented, there is a smooth transition between the existing procedure to the new procedure? Maybe this can be a question for integrators, or it can be something that we can answer.
If I take our case as an example, we made an offline setup of the merging cell. So we were prepared to install the merging cell inside of a volume line, high mass production volume line. But it has also the challenges to set up those cells and operation, especially the need for skilled people. It's high, and maintaining those kind of cells is very hard, especially in manufacturing is very focused on production. That's one of the stuff, and especially the close feedback follow of the system. It's also attention by the suppliers.
For us, it's very important that the people that work with the solution is help make. For instance, which is assuming the basics different move is a collaborative space with the. For us, it's very important that share the solutions.
Yeah, I think in the case of we have to implement new solution on the existing line, so we have to took care the people who were working on the line. We have optimal example of experience with customers who want to implement the robot, and a few months later they asked to move it because the people was not prepared to work with us. And in the opposite, we have different customers who prepare the people on the production line with robot with step-by-step production, step-by-step operation. And on this customers, the execution really was more simple. And after, we also have to be sure that the product we have to install is, like somebody explained this morning, plug and play, because we have always we use time to implement solution on site because of the production. And so we need, as an integrator, we need a plug and play solution. We need people able to make information and clear explanation of how it works. So good connectivity and good communication with the existing systems present on the industry, so like PLC, robot, and other components. But we have to need a good maintainability of the system, because the people who make maintenance on the production lines many times doesn't was open to new, not open to new techniques, but they know what they have on their plant, and they didn't they do not have any information to the new system.
No, yeah, regarding software integration, because there's a software development company. It's always complex to manage to integrate such different technologies into one solution, in one use case. It's difficult to have an out of the box solution that works for everything. It's always needed to work together to make all different subsystems communicate with each other. And for this, as Rafael said, we need good communication also with the end user where the solution will be applied. Now, regarding specifically for the emerging project, as we saw earlier, we have several different technological building blocks that we need to put together. Of course, we primarily are based on ROS, which is a common standard in this type of system. But again, we need to do customization for every use case and customization for every building block. And from the orchestration point of view, we went with the approach of having a broker in order to make it easier implementation for the connectivity for every software version.
We have integrated this current workflow, the collaborative tools. This question that one will ask is how safe are these robots when they work with humans, and how did you want to ensure that there is no accidents or something that can totally affect the operators by this course of information. And is it something that you have considered, or is it something that is a great importance that you will consider?
I think it's a European funded project that emerging. We are of course aware that not full safety is activated in cases. We made also the necessary risk analysis, of course. Regarding what the industry is demanding is that cells, CE mark is important. It's some sign that the machine is safe to use. It is still requirement. And of course, the operators and the people which were used and as proof concept. In this case, we are aware about the features of the machine. It's still there are 6 so it's just in the concept phase. Of course, it's our responsibility to show the people and people who are working with it to the danger of the equipment. But in general, safe use, of course, safe use, otherwise we wouldn't use it, but it needs some attention.
I agree. People first, it's important, the safety is important, but in Spain, for instance, the law is very hard with the implementation of the law. It's pilot because it's very important to save the production all the time.
Yeah, I agree with this point. But from our side, we have 2 different ways to integrate robots in the industry, depending of the robot to make operation near the operators, and robot to make operation really connectivity of the operator. So depending on these 2 cases, we have a different approach. So first, of course, there is analysis. The case of the robot is able to work alone. Generally, the solution is easy, so we can close the area, control people, and reduce the speed or make some kind of this modification. Since few months, we have other project with robot working directly in the activity with the operators. So we have started to make a measurement of the direct strength and the direct age, and the robot can provide to the operators and make a modification of the end effectors depending on this, depending on the part of the body and the robot can hit or not. So I don't know if it's enough clear or yeah.
So, just in our case, I totally agree with what you said, because the robots are working in an area which the operator won't have to go there. So we just limitate the speed of the robots when the safety barrier will be crossed. So we managed to make a risk analysis before, and that's all was concluded.
Well, the next question will come back to the main project, the flexible materials, that all 3 spaces that we have are handling highly flexible materials. The first question would be the flexibility that these robots have, or the solution that have been implemented in those spaces, whether it's sufficient, or would some different improvements in terms of the flexibility and in terms of the end effects that you wouldn't have, which are in the requirement. We want to see another new development or something that would push the boundaries and improve your machines as they are right now.
Okay. In the morning, we had on the grasp here, they were presenting nice electroadhesive gripper. So I see much more development in those kind of things at the current point. For the VL use case, you use some fake grippers, some needle grippers, and much more. But those are to this point good enough to execute the process. And in the future, of course, we want to see more developed some electroadhesive gripping to avoid the damage on the fibers, especially fibers stimulation or whatever, and also forming of fibers or stretching the fibers. There's also some elements they made future work on. So that can also be developed further, especially if you see what materials are available on the market. Every kind of material has its own property, so it can be more than now. But on the first side, I'm happy with the provided solutions from all parties, and it can always be better, and also more used for industrial use.
It's important for the implementation, there like a better developed solution to really this situation, shorter positioning, recognizing, and important resistance. Texas is very important. One implementation is thermal efficiency in the video over the worker very fast, and there are the robots is reach the people, but cycle time is very important. Key it's a first thing for the setup is necessary.
Yeah, we talk about the city later, so the presentation of this morning showed that each development we made during the last years, it's working individually, but like I explained later, so I think the next improvement of the EDG system is to create a more plug-and-play solution, so more easy to integrate. So, and that's all.
From my part, I agree with Rafael. I mean, the next steps will include to have a more plug-and-play solution that will be also easier to commercialize in the product. And of course, technologies are evolving, maybe some AI be included. That's ongoing.
And I will finish to another one because we have the issue in the materials. With the plastic, we have a lot of new kind of plastic that are coming in order to be more recycled. And those are some problematic for us because we have to update our kind of manipulation or kind of production of way to manipulate it. So that would be something that could be further in the future. For example, I told with Vito from Nitras during the lunch that we have some pouches that are non-woven just with small thin film of plastics. And I think those kind of approaches cannot be lifted as easily as the other one, so that we can go further in innovation. But what has been done so far is very well.
This might be a question directly to Andreas, because you mentioned that there is a need for the AI and machine learning and everything. So how do you see, because for these activities you would need lots of data, which can be corrected because we've seen the demonstrations of the VDN and other spaces where they show that we can collect the data for the human movement and everything, which will help in training the models. But we see that it is something which can be done very soon in collaborative modes as well, where the actions are being carried out simultaneously by the human and the robot, or is it something like how CA has developed, which will be actively just through action and then secondary action of the humans?
The point that I want to make is that, in general, there are some tests, including artificial intelligence and machine learning, but of course, there are some barriers because the data that we need to train be very big and quite different according to the use cases. It will not be easy. But as I mentioned, the industry would like to include in other options to reduce the costs. I don't know how it will be done. I know some other, for some other use cases, synthetic data, also the data they use for training the algorithms. It's something that we need to wait and see.
In terms of flexible materials, given that you have three different kinds of flexible materials, would you be able to use the solutions that have been developed for other flexible materials, like for example, in the case of radial, random max, or different kind of fabrics which can be used in the market, other kinds of garments or textiles for clothes or something? Do you think that is the market which can be used with current solutions that you have, or would you, are you seeing more different solutions that you have currently?
The morning we saw all the end user cases, especially in Selma. Also, Vito from Clasp told us that he made also several tests on glass fiber. So the electroadhesive, I think in this case is not applicable. Regarding the training purpose, it's hard. It's hard, especially with the state. At this moment, I don't see any other option that we have. Of course, we don't have to stop it developing. It can also be adjusted maybe in the future, or we have to add some extra materials to handle it. Of course, but at this moment, I don't see any solutions.
Finally, in our case, there are 5 lines of product. There are the fabric, the swimwear, there are opposite the fabric of the lingerie. It's very variability on different fabrics, and it's necessary works in this gaps of these different fabrics.
Yes, almost I didn't get the question, sorry. So
I was asking, like, you have a solution right now, and you see this solution with different materials or different types of things? Or
Totally, yeah. I think the famous solution now are expected to be some for other kind of pouches and other kind of way of doing stuff. And what has been developed from this project could be integrated on other kind of machines. I see an example of paper that could go in our commerce code aspect, because there are no vacuums, so that's better for some clean room. So I don't have another example, but this one.
we get back to the questions which humans think, given that we have always said that the project is around the human center, we are trying to include the humans in this process. Do you think, are you sure that when we are implementing the solutions within the industries or anywhere for the integrators, you already have spoken about this, but how fast can a human adapt to these solutions? And is it something that you see happening to be immediate? Or do you think there should be a long training session that will be required to be adapt? Or do you think you would require a new set of workforce which needs new capabilities or new knowledge to use these solutions that have been implemented in the project?
What we saw, seeing where we were testing the cell or using the cell, that our operators they were adapting very well, as I mentioned before. I was even surprised that people can adapt. But I saw a group which has some scale of installation. I don't know what it is, but there's some not familiar emotional frameworks which I cannot express what it is. You have those kind of people also. So I think to introduce this to all the people, all the operators, we should organize a training. Let them start one by one, step by step, explain the system, explain the future of the system, the use of the system, specification, and let them already with the system. Let them be a part of the system so they can accept it very easily instead of putting the system immediately alert and just say start with the use of the system. It will need more time. I agree with that. But the balance, of course, the environment situation. If you're already modernized in your company or your factory, it's more easy to implement those kind of things. But if you're more manual or more reliable operating, it will be also very kind of difficult to change.
Some markets, the work is changing, different prices, different process, different solution, and there are people very adaptive. It's important because there are could be scissors, could be machine, could be laser, there are scientists steps, and workers watch the solution with help, for them, for better. We have we are competition with the other brands, this working other countries, salary more or less, and it's necessary since productivity, and there are tools, there are systems solutions with help in this point of work. It is necessary also a partner, it's very important to collaborate with a partner, to explain better with support solution is more wide for the operator. It's very important because it's necessary. Share the travel for solution.
Yeah, I agree with the point of view of PDS. So I think if all people were included in the project early, it was really more easy to accept that. So this is the case for production, but also for maintenance and security, for example. But our experience sometimes when we try to implement a new technology, the most difficult way is security operation. For example, in the internal at our studios or by an external company for security equipment. So this has to be validated the security capability of
competence. From our side, I don't know what to say about this topic. Based on our experience, what I know is that when we have tried to install new solutions in some of our industrial customers, it is always difficult to make the work operate in the sense to just use, let's say, a user interface. So it's difficult, so it needs a training. Much more for this technologies that we have developed in manufacturing.
From my side, I think I can clearly answer to that question because I didn't have any answer from an operator. I cannot operator on the machine, so I don't know what could be the reaction to those kind of technology.
We are almost to the end of this session, so I leave the floor to the audience. If there are any questions from the audience to the panel, or online, if there's some questions online to the panel. If there are no more questions, I thank you all to participate in this roundtable. It was nice to discuss around the topic of these solutions. Thank you.
So thank you very much, everyone, and all the participants of this roundtable. So we're going to do that now. We have a coffee break for let's say around 10 minutes. I remind you that afterwards, just after the break, we will have the tutorial sessions. And there are two parallel sessions. I would suggest so one in that room. So this is the letter A, and one is the robotic lab. So what I would suggest at 4, the people with the letter A will stay in that room, and the people with group B go with you. And I would suggest that we meet just outside in the lobby. That's okay? So thank you again, and let's see in 10 minutes.
On a 3 sessions ici, on a 3 présentations. Ok.
La première,
ouais, ce sera OmniGrasp.
Sure. Yes.
As a speaker,
as a speaker,
he wants to be a student
nice. Yeah, that's so I'm doing introduction. I think it's nice if they can talk, so that if there is any specific question, they can just yes. I give you the name.
I think they are connected already, actually.
Okay, so what's the email?
Fabio?
That's one point. Ce que je dis, c'est que les tutoriels où vous avez donné, c'est vrai que les censés sortir à 8h30.
Ouais.
Donc, à une demi-heure de code. Sinon, tu les. Je sais pas pourquoi on a dit ici. Donc, soit on les ramène ici, soit vous commencez par 4 heures, et vous les ramenez en fin. Parce que toi, ça va faire bizarre, s'il y a une demi-heure de creux, ils vont partir.
Donc, une demi-heure de creux, quel moment?
Gargano is G-A, and O.
Just a sec. No, he's already a participant, so
Yes.
we need to remove it as a participant.
Can't we promote?
Yeah. We remove him from here.
Yeah, for the right, okay. Yeah.
And now I will add him up.
Juste une petite école à regarder ensemble, là, puis après,
Profitez de la pause café. Je regarde son département, mais il faut confirmer.
oui, César, où il avait fait Christine. César.
L'apport fait le tour. Il y a eu des premiers sondages, il n'y a pas eu de confirmation. Face à la liste,
You must have an email and you need to register as a speaker.
Donc, en termes d'agenda, on commence à 16h, 16h, 16h30, 17h, et en fait, on a session B à 16h30. Ce que je te propose, ouais, on remonte tout ça à 16h, et puis après, on peut remonter.
Oui, on pourra discuter un peu plus.
Tu seras là pour l'événementiel là? C'est bon.
I was worried to be late.
No,
Coffee
that's
break.
me. I'm late for the cookie break.
Yeah. There is still coffee.
We might not see before tomorrow because I will go to my room and after I will actually because of constraints on my side. So I will not go with all of you for the dinner.
That's too bad.
Yeah, sure, but I'm alone with my daughter and my husband is very, very far in France and we can come back for this night. So.
I understand. Family first.
Yeah, she's too small to stay alone.
How old is she?
12. And I have to coach her to the school and it's, I don't live near the lab, so there's roads and
Okay, I understand. I'm lucky that my wife is taking care of my kids while I'm traveling.
Yeah.
So that's why I understand the struggle.
Yeah, and it's a difficult situation because it's 20 years since we are living like that. And so, yeah, when I had to travel, it's always a big prize because he's like you with teaching research. Really nice. So he's graduate outside. He comes in with all kinds. And so when I have to move for project outside.
Yeah, because you need to travel as well.
Yeah. So hopefully we have a period, I could say. But before that, it was hopefully when she was very big. It was even my our parents are so we cannot control them. So, can you give your course administration change the
I'm lucky because my wife is a high school teacher, so she doesn't need to travel. So in our case, I know it's a luxury for me because I can travel very easily. But when I always think that she was in section like me, it would be so complicated to be able to travel. I didn't so I can sympathize.
Yes, I would
yeah, of course, we do especially, yeah. Apology that.
Because most of I went to see all the once.
Yeah,
just for the first and then the thing.
That's what I was doing today. I was it's so nice to see people in person, it's just so different. And the distance is very difficult, not knowing each other. It's okay to work with one video and but not knowing each other. It's so hard. Yeah.
And we have a lot of people who have moved, who are changing the project. So most of them are not there.
I know.
Yes,
I remember them.
yeah.
For tomorrow, I didn't see them.
No, I because I'm working it out. But I start learning, and I will maybe focus on the project, and I would like to also sometime we want to discuss on the next things needed.
Okay.
Yes. Not
yes.
And then now
Yes, yes. Yeah. Yes. No, it's because I'm getting used to because of my small child, so my baby. It's very difficult.
How old is
Almost 3 years. He's still he is sleeping 6 hours in a row. Before, every 3 hours he was getting up for resting.
Okay.
Very hard.
I have a child. I have a very young brother. It's like I grew up all the time.
Okay.
He's here, so
Oh, okay.
when he was born, was I think
It's like actually taking care of
yes, yeah. It's like you became a father without thinking.
So you have experience that.
Yeah, I do have experience. I think there will be a really long time when I have the example of my own because of that, but I really present the experience. Now she's 9 years old. But I remember this phrase.
People say to me that it's even harder after. Because of other kind of problems, of course, not because of
I think that depends on the humor. And I mean, how
maybe yes. Yes, I'm experienced. Sometimes you want to kill him, sometimes you want to cure him.
Sometimes she looks that way and everything is in the hand. I've never insulted my brother. I cannot do that. No matter how stupid things I cannot.
But this is because of you, because of your father told you that.
No, I think it's. I see. He was a little boy. When my mother did not allow him to do something. To his eyes, I'm different in this relationship.
So,
yes, when I see something, he has no.
His thoughts, for example,
my mother now we don't say the same. And when he doesn't, my mother calls me. It says, make a photo of your brother. He's not a good boy.
Yeah, I don't know. Yes, this night I wait and I walk.
It doesn't matter, my English is a little more so.
And you wake 4 in the morning. And stay lay down on the bed this side. Strange.
Doesn't he look for you when you're away?
What?
Your son, does he look for you when you're away or?
No, when I was younger, my mother told me that I used to sleep very, very well. I didn't move anything during the night. Has a lot of energy. At least more than his mother.
That's the case. They will not stop. No matter how much no mess.
Yeah, this is the one. You are starting to be tired and exhausted at 8 in the evening, but the boy is still. I want more feast.
Yes, I play.
Yeah, play.
One day verified, you know, which time was, maybe, yeah, it was, I think, midday or afternoon. I think, yeah, yes, I will say
Sí, sí, no, mejor. Sí, sí, sí.
Pues está lo humano, porque yo incluso me dieron y dije, lo mismo, y joder, después esta actividad, yo si debo ir cuando hay tengo que flipas, yo hago flipas con ellos y lo hace siempre con el control, yo para mí yo
Yes, yeah, it would be better with guys.
Sí, 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 es así, ponía, tú sabes, lo bajabas y lo hacías. Sí, sí, sí.
Just for the
meeting at 19 school. I will not be
hay puntos que están en
Sí, está un poco. Sí, pero están súper guay.
Thank you for coming.
Si debes de que
So, would you guys have to go? Yeah, that's up. I will just props.
Introductions. Our props for people from the audience from the more connections. If you don't mind, we use old-fashioned system.
That is not working, so
Yes, that's it. So thank you very much for the happy few that left for this session. So tutorial session. So and so also thank you very much for people attending this meeting remotely. I hope you are still there for this sessions, tutorial session. I hope that will be quite interactive with the audience. So we will start by OmniGrasp. So Vito, that's your turn.
Thanks a lot for the introduction. Let's make it quick. So it's mostly giving you some inputs on the grippers that we have seen already this morning, taking a look at how they are made, how the connections can be established, and this mostly for you to ask questions about the current usage of the gripper or future usage. If something is not clear, this tutorial is just it's an opportunity to have an exchange on this. Well, you have seen it in action already, so that's one of the videos done at Salmac last week. So there is one for textiles, which is here, and one for pouches over here. Both grippers share most components. Just the design is a bit different, but the key elements are all there. So both of them have a case that holds the electronics, which is kind of a cubic shape. So all the electronics needed to operate the gripper is, apart from USB for communication, is included in the case. Then the pouches gripper has a soft pillar on the top of which the electroadhesive is mounted. And the electrical connection to the electroadhesive is done by two flat cables, two flat wires. And while the textile grippers has that same structure, so there is also the electroadhesive with the flat wires. In addition, there is one movable finger that closes on the electroadhesive to hold the fabric in place. As I've shown this morning, they come in a compact package with a few components. Let's take a look at what they are. So there is the gripper itself, which is one component. The parts with the electroadhesives are designed to be replaced without having to change the whole gripper. So if the electroadhesive gets damaged, since they are the most delicate part, they can be removed by using only two screws. In the case of the Timonier gripper, we need to open up the top lid, so it's 4 screws, and then the electroadhesive can be taken out and replaced with a new one, and the gripper is again good to go. Then there is one little box here that the people who have used the grippers have seen already. Those boxes include a 12-volt power connection with a standard jack and the USB-B connection for data. They connect to the gripper, sending both power and data using an M8, a cable with an M8 circular connector. So it's a long cable. In this case, to simplify the integration, we used those cables that run along the robot arm, but the grippers were actually designed initially to work directly with the communication that we can get on the wrist. That's why we are using 12-volt ground and the plus and minus serial, so that we could just use 4 lines, 2 power lines and 2 data lines that are available on most robot arms on the wrist. And in this way, we could avoid communication over the arm. Then we provide a power supply, but any 12-volt power supply is okay, as soon as it can provide 12 volts. And here is the cable for communication that we are now using. It is currently an external cable. These animations show how to assemble the gripper. We first screw in an adapter it's a component that can be 3D printed very quickly to match different robotic arms, so that the gripper can be adapted to any design of robotic arm. And then there is just 4 screws from the sides that hold the gripper to the adapter. So simple. So in total, it's 8 screws that need to be screwed in for the gripper to be fixed. So it can be done in literally 5 minutes. And then the same happens for the pouches gripper. Again, first fixing the adapter, and then the 4 screws hold the gripper on the robot arm. And the following step is to connect the M8 cable to the gripper and to the communication box. The communication box goes near the operator, near the computer, and then the communication is done by USB, and the power using the wall power supply. All the electronics is here in the main case that goes on the wrist. Here is the structure on how the gripper communicates with its different components. So the electronic box has a microcontroller. We use an Arduino Nano Every because it's simple to operate and we don't need high performance. The microcontroller communicates with the ROS using serial communication over USB, and the microcontroller takes inputs from the touch sensor, which we didn't implement in the whole system due to time constraints, but we tested it standalone and it works well. It controls the DC motor in case of the textile gripper that opens and closes the gripper. Takes inputs from a current sensor. That is the way we control the DC motor is using a current sensor. We don't need any fine control. We just need to know if we are open or closed. So measuring current spikes is enough for us to understand in which of the two states we are. And so it's enough to provide the feedback to control the opening and closing of the finger. So we go at maximum speed until we detect that we are either open or closed, and then we modulate the current with a PWM to avoid overheating the motor. The microcontroller also controls the opening and closing of the activation and deactivation of the electroadhesion on the HVPS, on the high voltage power supply that we designed, so the new board that we designed. And finally, there is a motor shield to control the motor. On the bottom here, there is the graphics for the ROS architecture. If you have questions on the ROS architecture, there is my colleague Fabio Carcaro connected that could answer it. So Fabio developed a ROS package for the operation of the gripper that is on GitHub. Here you can see a screen recording on when the gripper, the ROS node for controlling the gripper is actually activated. You see that it just lasts a few seconds, so it's important to detect on which port the USB module is connected. Then the module is launched, and it's started. Now it can take commands to open and close the fingers in this case, or activate and deactivate the electroadhesion, which is not visible. So in a few seconds, the ROS node can be launched and the gripper can be operated. And that's basically it. It's just another chance to thank the fantastic team at OmniGrasp that made this quick, successful development possible, and be happy to take any question and clarifying doubts, information that you might want to know. Thank you. Questions? Yes.
Do you think this kind of gripper will be applicable to stiff materials? Because we know that it is working for the flexible materials, or let's say materials which have a flat surface. Let's say if it is paper or a plastic sheet which is kind of quite thick, do you think this gripper would be able to handle such kind of materials?
So you're talking. It depends on the material. So let's be a bit more specific. So you're talking about like a plate.
Yeah, just say it's like a plate of plastic.
Yeah.
Would it still work? Because technically it's the same material, but it is just it's more rigid.
Mm-hmm. So yeah, the gripper for the pouches would work, I think, pretty fine. The pouches gripper would work depending on how thick it is and how big it is. We might need to use more than one pouch, more than one electroadhesive. But yeah, I don't see any problem. In this case, it's designed such that it's the electroadhesive that adapts on the object. So we are not taking advantage of the flexibility of the object very much. So we tested it on flat surfaces and it generally works well. It's just, well, if you want to take things from top, there is still some advantage because it's not easy to do that with many other grippers. So I was going to say that it's generally easier to grasp rigid objects than flexible objects. So that's why we focus on flexible objects in the project. But yeah, for the object that you describe, I think it would work. Yeah.
Just to remind myself, the exact difference between the two different use cases for gripper design, which is the placement of the placement and functionality of the outer module of the gripper and not the electrode. I didn't see it.
So we are using two slightly different electroadhesive materials. The electroadhesives are made with different materials. So they have the same design, but we could interchange them, but we figured out that to get the best performance, it's better to use one material on the pouches gripper and one material on textile gripper because they are different. For the pouches, it's important to have the maximum flexibility for the electroadhesive so that it can conform well to the shape, because the flexibility of the pouch itself is not very high. While for the textile, we don't use the electroadhesive is not going to deform. It's the textile that is going to deform to the electroadhesive. So in that case, it's more important to have a higher voltage because we need to hold on textile, which is sparse. So there is less surface area.
One last question to finish.
Yeah.
Still curious because can we adapt the gripper size? Let's say if I have a larger surface to handle, or let's say will the system remain the same, and we just have to change the skin area, or do we have to change the whole setup? Because as in maybe I'll rephrase the question. Are the electronics within the housing of the gripper are sufficient to handle a larger surface area electroadhesive skin?
Yes. I mean, of course, define larger, but if we are talking about...
Let's say, because
yeah.
Let's say it is 1 by 1 centimeter.
Yeah.
If I say 10 by 10 centimeter...
Yeah. Yeah, no problem. Yeah.
Okay.
Yes. If you're talking about, I don't know, 5 by 5 meters, then I don't know. Then we need to check.
No, of course not.
But if you're talking about within one order of magnitude of difference in size, which becomes kind of 2 orders of magnitude in difference in area, I think it's gonna be fine. I don't expect major problems.
Okay. And the skin is it's like plug and play, or as in like can you just change the one of the skin and with the same housing?
Yes.
Okay.
Yes. Where the skin is made, the electroadhesive pad is made to be removed and placed back. So that also because it's the most advanced component in the whole gripper, and so also the most fragile, is the one that can get damaged. So it's important that we are able to replace it if it gets damaged. So we designed the gripper that way, so it's easily replaceable. Ideally, we wanted something even more plug and play. Now we need to unscrew the top lid, and then it's a bit manual. We have to remove the connection, plug it out, and then plug a new one in. But it's still easy enough. It's kind of 10 minutes operation, but we don't expect that this has to be done very, very often. But we could even do it faster with a magnet, let's say, or magnetic connections, and both mechanical and electrical. Yeah. But thanks for the questions. And just for handling a larger surface, my approach would be to have more electroadhesives rather than one larger electroadhesive. Yeah, I think in general it's a better approach.
Because it's easy to unpeel, or what is the reason?
There is a few reasons. It's difficult to fabricate a large electroadhesive. Okay. Yeah, so that's already one reason. I think it's easier to build, generally speaking, a structure with many electroadhesives, also because you have rotation problems. And since you want to be attached at the center, if you have one large electroadhesive and you're only attached to one point, then the whole thing is going to rotate very badly. While if you have many, then you can control the rotation. So I think that's, yeah.
If you have many grasping points, what is your recommendation? Because the simplest way would be to have a frame, and then we have all the grasping system. Yeah. What's your, or perhaps many robots? I don't know. What's your feeling?
If it's just one rigid object,
flexible object.
If it's flexible, well, it depends.
Let's say, as an example, the fiberglass from BDL, you have 3 meters by 2 meters or whatever.
Yeah.
This kind of object. My question is, in that case, would it be sufficient to have one frame with many, I don't know, perhaps 6, 8, I don't know, zippers, or do we have to have 2 robots with frames?
That's a good question. So if it's starting flat and ending flat, one might even just design a frame, which is cheaper, but I don't know if it's very practical and very robust as a solution. So maybe, I think it's maybe better to have more than one robotic arm. As we would do, it becomes a bit bulky. Then for that kind of sizes, I think, yes, having at least two arms with a bit smaller frames, it's probably better. It's more flexible as a solution.
Other question from the audience? I have many.
Yes, I have one question. When you switch off the electroadhesive pad, how long is the part, the grasped part with electrostatic charges on it? Is instantaneously discharged, or remains for a while, I don't know, 3 seconds, or I don't know?
Maxwell equations have been developed in vacuum. The theory of electrostatics in dielectrics is still not a very well understood physical theory. So there is a huge body of research trying to understand how electrostatic charges and polarization in dielectrics work. So we have a practical empirical approach depending on different materials, but it's very difficult to understand. It depends on all the materials that you have. It depends on the dielectric that you have on the pad. It depends on the material that is your object is made of, and the difference in dielectric constant and the dissipation factor in both materials. They combine in a pretty complex way. It's very hard to predict this. Practically speaking, we tend to use AC to avoid too much residual polarization, and it works in most of the cases. So most of the cases, the object can be released quickly. But there is cases in which charges still build up, and we still don't know well why. And those charges building up create problems, and I mean, it's difficult to release. So it can go from milliseconds, very quick, to a few seconds, depending on the objects that we handle, and depending on the frequency we operate the gripper at, the electroadhesive at. That's an important parameter that we control. That's why it's important for us to always have a release mechanism that goes beyond just electrostatic discharge. That's why for the textile gripper, for example, we also control the angle. This is helpful for both grasping and releasing, because by controlling the peeling angle, we can make the electroadhesive unpeel even if there is some residual charges. And this makes it possible to release even though there might be charges over there. That's more difficult with the other gripper. So that's for the pouches gripper, we are investigating more in depth the charging and how one has to do it for the specific materials that one needs to understand it. But the good thing is that there is many people interested in this topic now, because the field of electrostatic actuators is very active, not just electroadhesion, all kinds of electrostatic actuators, and they all have this problem. So it's a common problem for, I don't know if you've heard of the electrical elastomer actuators or Hazel, axles, zipping actuators, they all have this issue of how fast is charging, how fast is discharging. And so hopefully in a few years, we will have a even better grasping, pun not intended, of these dynamics. Thanks for the question.
One last question for Vito. I have one.
Yep.
Regarding the VDL application still. When I see this kind of picture, for sure I see plenty of application, but there's always one question about the positioning and precision in positioning Y, in X, Y, but also regarding orientation, because you have fibers, the fiber gives the properties, and if you have a misorientation, then you might have lots of right properties for your table. So do you have insight about?
That's a good point. So one of the advantages of this technology, in my opinion, is that it's tolerant to positioning errors. So we don't need a high precision in positioning for the grasping to happen. So we can tolerate millimeters of misalignment and we still be able to grasp the object. We design the gripper that way. Of course, the problem with that is that being tolerant of misalignment means the gripper is compliant, so it's not as rigid and precise as a rigid gripper. So grasping, it's easier for complex objects, but then the positioning is not that predictable. Well, there is ways around this. One can compensate with vision. So one can have a sensing that when you put the object in place, instead of making everything fit forward, you get a feedback and you can adjust the positioning. You need that vision anyway, right, for the grasping. So one can duplicate it also for the placing and adjust the orientation and position of the object as a consequence. Or having with one object, you can see that one gripper, you can see there is a lot of movements. We added these pillars that were not implemented in these videos for time reason, but I think they will be implemented in the final version when they are on the other presentation. But essentially, I can describe them. Those spaces that you see here, they're meant to host silicone pillars similar to the one that holds the pad at the center, and they are just meant to avoid these unwanted rotations of the object. Having multiple grasping points, of course, increases the stiffness of the grasping, so the object can't rotate freely. If we have, for example, 3 grasping points, then the object can't rotate at all. So even if each point can transmit torques, if we hold the object at 3 points at least, then the whole object can be held in place. So the 3 points gripper can compensate for torques. Of course, the build-up is a bit more complex. The control is a bit more complex, but it depends if the application requires more precision or it's better to have more simplicity.
Thank you very much.
All right, thanks for the question.
I think we should go for the next presentation, the next tutorial.
All right.
Bye, Philly.
Thanks, everyone.
Thank you, Vito.
Yep. Thank you very much, Vito.
My pleasure. Thanks for all the interesting questions.
So, yeah, you have your videos. You have your videos. Everything is okay.
Yeah, these are the videos.
Yep.
I think it's enough. I don't have anything else.
Yes, you just have
Yes,
to
open with.
open with.
Right.
Avec.
Okay. Yeah.
And we suggest.
Yes. Yeah.
Okay. That will be okay?
Yeah, just for me. It's
I'm
okay.
just staying here.
Sure.
Just in problem.
It does work?
No, not this one. You have
right,
to use
okay.
this one. The more.
Okay. Good afternoon, all of you. First of all, I have to say sorry because we didn't prepare nothing. We thought this morning that we have just to prepare our presentations of the morning, not just this on this afternoon. But what I'm going to do,
to fill this time is to show you some videos regarding the different building blocks about the perception, more focused on the CERMAC use case as well. We have 3 videos, one about the perception of the stack of fabrics, which is this one. This is a video recorded at IMM premises. We have here the press, the mock-up press, which CERMAC sent us to simulate almost the real environment, likely at CERMAC premises. And for example, this is the first steps before the. This is the quality. No, don't worry. This is the quality recording video about how we measure the deepness of the bra caps already performed. And first of all, we have to put the bra caps in the correct position. If there are wrinkles inside of the quality base, we blow air with a small fan on the second robot. This is the information we extract from the camera. It's a 3D camera sensing, and we get the point cloud of the fabric, as we can see on the video. Now again, I think it's the same sequence, but with other fabric. I don't know if this one is correct. The deepness of this fabric is correct or not. Now the cameras are fixed on the robot here. Now is the accurate cap shape. These are the different caps extracted from the point cloud. Yeah, you want to explain something else?
Yes, here I will try to share our screen. Okay, yes, that's this. I don't know how do we show
Yes,
here.
you should first connect.
And sharing. Right,
Okay,
it's here.
behind.
Behind.
Okay,
Yeah,
perfect.
okay, in this image here, this is a point cloud visor. This is the point cloud that we obtain in this module with the photonio camera, as you can see here. Here we have a lot of noise. An advantage is work with 3D sensor. If we are working always in the same scene, we can delete a lot of information. This is all of this is noise. Then it's just with some bandpass filters we can delete. And after that, we obtain this. This is just the fabric. And to do that, we don't need anything hard. It's just fix some points, and after that, we just filter. After that, we calculate the plane, the top plane. And this is with a mathematical method called ransack. Just delete some points of noise and try to fit all the points to a plane. And after that, we have the caps 1 or 2. To obtain this cap, we just fit these points to a sphere. Okay, as you can see here, our algorithm. Okay, I will execute again. This is the execution. We obtain the spherical equation. Is this? We also. Sorry. You cannot see it. Maybe I need to share. Solar window screen. Enter screen. Okay. Oh yeah. Infinite.
All right, now it's working.
Yeah. Yeah. Okay.
Now it's working.
Execute again the program. The time is fast because we have the visor and it's slow. And this is our final results. This is the equation of the spheric of one of the caps. This is the equation of the other sphere. Here we have the point of the dip. This is the dip from one cap, and this is from the other. I just draw before. This is one sphere and the other sphere. As you can see, the point cloud fits to a sphere. Perfect. As Selmar people told us, the cap must fit to a sphere. They don't have illicit forms. There are spheres, okay? As you can see here. And after that,
discussing this topic.
And after that, we have the point of the deepest point. These are here. These small points are here. Is you and I can activate again the cap, as you can see. And we can use the visor to validate our code are in the deepest point of the sphere. To do that, we just don't need, for example, some artificial intelligence. We don't need nothing of that. This is only mathematical methods. It's just plain geometrical equations, and it's not probabilistic. It's always work. The main problem here, we only have an accuracy of 1 millimeter. Okay, but if we have a better sensor, our accuracy will be better. We don't depend here from light. We don't depend here from another type of external source. Okay, I will stop and we will talk about another. I continue sharing, no? Yeah.
We can switch. To
yeah. No.
Yeah, and now where is the folder? Here with the other video. Oh, right, yes, here down. This is the other video we took at.
No, please.
Yes, sorry. Close.
Otherwise, here
Yeah,
charging.
it's right. Yeah. Ouvrir avec DLC. Thank you very much. This is the other video we took about the perception on the stack of the fabrics before thermoforming process. The operator put the stack of the fabrics in front of the press in an area where the robots can reach these fabrics. These are the cameras here in this position. We can see better the camera, the Photoneo. It's a 3D sensor. Now the camera is analyzing where are the stack and the first fabric on the top, which is something not too much easier to distinguish between the first and the second layer of the fabrics. And finally, they give us the correct grasping points to the robots go and grasp the fabric. We did different trials in different positions, rotating the fabrics as well with different kinds and types of fabrics. Just to let you know that it worked very robust. This model just have problems because with the thinnest fabrics, less than a millimeter. But this is something inherent to the sensor, not because of the software developed by IMEN. This is another fabric different.
here detect the border, and these are the grasping points to the robot. Maybe we can jump a few seconds more, because almost is the same. It's very repetitive.
Yes. I don't know. This. Sorry. Yes.
I think there are another one when you turn the stack. Yes, this is when the stack is turned, for example. The perception works perfectly well as well. And I think it's nothing else.
No, this.
Yeah. This is a diamond, the same a diamond working, a diamond, Selmark, sorry. This is the robots working, already working at Selmark premises with another kind of stack, with another environment, and the model is quite robust to work as well without any changes.
I'm sorry, there's an issue. They cannot see the screen.
Right, okay, sorry.
Sorry.
The video.
No. All right.
Still, I guess there's an issue.
Sure. Sure. Now it's working. Yeah.
Yeah.
Yes, now it's working. Okay.
This is the last one.
But I
video.
Ouvrir avec.
Yeah.
This is about the perception of the human perception model. We have two cameras working on the surroundings of the robotic cell. This is the vision from one camera. This is the vision from another camera. It's a stereo vision, so we are able to locate the worker, which is here, and we can put a 3D model just in a 3D environment here, calculating where is regarding the robot station. We detect some difficulties with this model, because when for example, the robot is occluding to the operator, the tracking people doesn't work perfectly, and this is the reason, because it sometimes disappears. It's something that we have to improve more in the future, adding additional cameras, at least one more in different positions, and not working just with two cameras. Here as well, when there are other kind of obstacles, the tracking system doesn't work correctly. And this is connected to the speed and separation model software as well, to be able the robot to change the speed when the operator is too much close to the robot, or even to stop the robot when is touching, for example. These are parameters. The distance from the operator to the robot are parameters that we can change, and nothing else, nothing more to say about this. I don't know if you want to say anything.
Okay. Yes. Okay. To improve the system. Is in this video when we save the information, we deactivate the tracking system. Okay, when the
the person disappear, normal the tracking must be active, and then you can follow the person. Also, we are using here computer artificial intelligence to detect the people, and we are using a camera filter as a tracking because it's fast than, for example, another type of artificial intelligence algorithm. If we need improve more, it's just introduce some artificial intelligence tracking. At the same time, add more cameras is not complicated. We just need to find a position to put in the installation. Sometimes it's difficult to put or find any place to install cameras. There are also workers working, and it's not good saving the areas where the other people are working during the project. But it's just put more cameras, nothing more. It's the same algorithm with more cameras. At the same time, if we put another, I think in Selmar's use case, we only need one camera more, and we don't have problems with the occlusions. Okay. There are some questions or something like that.
On this last point, so if you integrate more cameras, how does the integration work? Do you need to modify the algorithm in order to include the new camera? How much changes
No,
do you need to do?
because in ROS, the camera as a service, then we can share the same camera between different algorithms. Then we just need to put another camera, and we just improve another program with the other two cameras configuration to work. And it's just we have if we put 3 cameras, we have working 3 stereo cameras. Okay, it's just 1 and 1, 1 and 1, and 1 and 1, and then we cover all the. I think we cover all. It's not hard. The main problem maybe is we need sometimes. In this case, no, because we have space in the GPU. But sometimes we need to buy maybe another GPU, or just we can use edge device to execute the artificial intelligence by every camera. But the algorithm is still the same.
So you're using a dedicated GPU?
Now, yes, because we have a big server there, but we also did some proofs with JSON ORing, and it works without problem. Just maybe we need to only use the JSON to use the inference, and the matchings and the rectifications just move to the server. But this is only CPU problem. But it's just, and after that, just send the message.
In the Selmar system right now, you have the server over there?
Yeah.
Okay.
Yeah. Just a server is. Now you cannot see there, but it's in the back of the press. There are a
big rack, a big rack.
And could you use the 3 cameras, 3 stereo cameras to the Jetson handle, all the 3 of them, or you need 3 Jetson?
Okay. Now we test 2 cameras with 1 JSON, and it's working. But the velocity is like 10 FPS. It's quite. Yeah, it's not so fast, but this is still real time. In the server, I think we just try like 2 cameras. We have enough time without problem. It's like 60 or FPS. It's not a problem. If we have only, if we add just, I think it's if we want to use a lot of cameras, like in a big plant, I don't know, 10, we can just buy one JSON by every camera and then just send the information of every detection. And after that, do the match between the cameras in the server. But it's just send ROS message with the detections.
Yes, I have one question regarding the 3D camera. We were discussing this during the lunch about the light, and you were saying that this 3D camera is not sensitive to light change and so on.
Yes.
My question is, how does it work, this 3D camera? Does it mean that it's not invisible?
The 3D camera emits a pattern, and after has another sensor who capture how the pattern is modified.
Okay, so you are.
It's like an infrared light emits in the.
You send an image with a pattern.
Yeah, we don't send. The sensor is a commercial sensor. Okay, and it doesn't have problems with this type of lights normally, or less problems, but has problems with, for example, sometimes if the surface is quite reflective, can be problems. Okay, maybe you need to change the power of the laser, but you are working always in the same structure. It's just offline configuration the first day, and it still fits.
Yes, regarding your question as well, Roman, at the beginning of the project, not at the beginning, but in the middle of the project, we went to IMEN as well to check which were the lighting conditions there over the press, and we detect that we have several shadows from the lights on the top of the fabric. So this is the reason we decided to install on the robot. We can see there is a light here, a bar light here made of LEDs to avoid these shadows, to avoid any problem with the detection of the fabrics inside of the press. Okay, but finally, when we went to Cellmark to integrate the robotic cell 1 month ago, finally they changed the layout of the thermoforming area, where they have several presses, and they decided to turn a little bit or change the position of the press inside of the layout. So now the light, ambient light, changed enough to avoid using this light on the road. So just to say that, and the 3D camera started to work perfectly well without the light.
Okay, now in the video, I think here you can see the laser.
Yes. There is like a trigger.
Yes.
In red. This is the light.
Yes.
The light bar. Now it's triggering with a laser pattern light.
I think it's a laser pattern.
If it's a laser, there's no issue with the safety?
No.
It depends on the class of the laser. This is a lower safety laser. So.
Okay, there are some problems, but don't look directly to him. Better for you. But you can use in every place. It's not a problem.
Any other question?
A quick one. So based on your description, the solution works greatly. Maybe one drawback might be that the computational resources needed by computer vision are quite intensive. Do you have any idea for what direction one could take to reduce the computational resources needed, but still being able to achieve the task? Is there a way to make the cameras, to use cameras that are less computationally expensive, for example?
Que sea una forma de reducir la computación.
Yes. For
Las
example,
cámaras tienen mucha resolución.
yes. For example, in 3D camera, one of the best is just we show at the start with. In this case, we filter all the noise without. It's just we only need 2-3 centimeters, or not in this case more 10 centimeters. Then we delete all the information. Here also, if we use 2D camera, we have a calibration between the 3D camera and the 2D camera. Also, if we are working with 2D information, we can use the information obtained by the 3D camera to delete at the same time, also in the 3D image, in the 2D image, all this noise. And we can work with a small image. Then you don't need this computational cost. The other thing is, for example, as we say at the morning, when we are working with well-known environments, sometimes it's not necessary to use artificial intelligence. Then it's better use another solutions, because one of the reasons that we're using, for example, in VDL use case, in the small border detection fabrics, we don't use artificial intelligence is because the GPU was full. Then we just use geometrical transformations, and it was working.
The bad side of artificial intelligence is expensive.
It's quite expensive, and for me, on my point of view, the artificial intelligence is very good if you have line changes conditions, and if you don't know how is the scene. Okay, for example, in autonomous driving and something like that, is you don't know nothing about your environment, then it's very important.
Okay.
Okay, finish.
Okay, thank you very much. Thank you very much for your very nice presentation, and very well done regarding the time you have to prepare. Last presentation today will be yours. LMS. Let's close there. Thank you very much for this presentation. Yes. So I think we need to stop and restart showing the screen. So that's the same for you. You will need to use this one.
Okay, that's okay.
Otherwise, people from the audience will not understand, will not hear you. Oops. Should be okay.
Hello, everyone. It's Konstantinos Kavathas from Laboratory for Manufacturing Systems and Automation. This is a tutorial for the deformable object handling controller. I will refer to it as doc because it's a long name. I will give you some more information on this module. I will try not to make it too technical in order to have a better contact with it and interact more fluently. So, doc is a tool mainly intended for orchestration, and also has the target of providing the ability to the operator to orchestrate, to monitor the execution process. One of the main goals also is to make it independent from use case specific dependency packages and stuff like that, We want it to be easy to deploy and transport from one use case to the other without requiring significant effort. And this affects various decisions, but we will talk about them in the next slides. Another interesting aspect is that doc is scalable. We can control highly complex execution flows without requiring significant computing power, or at least that will not be the bottleneck in most cases. Also, the initial intention is to have a package that is easy to use by users that don't have a program background, or even by operators. So we have some intuitive interfaces. We'll come back to that later. One of the main aspects of doc is the hierarchical approach. There are 5 levels of abstraction: orders, jobs, tasks, operations, and actions. Those abstraction layers can intuitively correspond to real-time activities. For example, the lowest abstraction layer can correspond to simple things like opening or closing a gripper. The upper abstraction layer to more complex flows that require 2 or more actions, and so on. Also, to increase and enhance flexibility, every abstraction layer can comprise activities from any one of the lower abstraction layers. Another important aspect of doc, which enables it to have scalability and various other characteristics, is the utilization of the actor model. When following this approach, the module is separated into independent entities, the actors, and those entities interact only through messages. This results in independency that allows for one entity to continue executing no matter what happens to the other entities. This also results in high parallelization capabilities, and again makes scalability easier. It's also possible to distribute execution along multiple machines to distribute the load. I will go through some basic functionalities of doc. I will try to make it simple and squeeze as much information as I can to this time slot. This is the installation procedure. Of course, we will not go through every step, but it's just to mention that only 5 simple steps are required to install doc on any PC. I think almost no one had issues deploying it. There are no dependencies. It's easy to have a running instance on a PC. So the lowest abstraction layer, as I mentioned earlier, are the actions. They can have different functionalities. They can be ROS related. They can be a service to activate or deactivate a module. They can publish a message, or they can alter parameters values and stuff like that. They can also control the execution flow. We have some specific actions for implementing loops and counters, and I will come back to that also later. An interface is implemented for creating actions with the intentions of having people, for making it easier to use for more people. To create an action, the only thing required is to fill a form with the required details. I will go through some basic actions now for that doc supports. One of those is the set bool action. It's based on the ROS set bool standard service. This choice happened because, once again, we don't want to create dependencies, and when using ROS standard services, this is a lot easier. So we have the set bool action. We have to specify some characteristics of the action in the corresponding layout, and we can use this action to activate the activate modules and stuff like that. In the familiar way, we have the trigger action. It utilizes the trigger ROS standard service. It works in a similar way with the set bool action, so not a lot to mention about that. The delay action, self-explanatory. We have to provide an action ID and a duration, and the execution will stop to that action for the specified time. And the store action allows us to alter a parameter's value. It's proved to be really useful in various scenarios. There will be an example regarding to this later. The set parameter action is used to initialize a parameter before the store action most of the times. The compare parameter action is used to compare a parameter to a given value, really useful for controlling the execution flow or for taking decisions regarding on the execution status on the corresponding moment. The set mode action, again, needs similar fields to be filled with the trigger action. This action is not based on a ROS standard service, but does not create dependencies. It's handled and is also easy to deploy. The load YAML action enables the user to load a file containing various parameters and initialize most of the times the system. This allows us to have more dynamic schedules. We can have the same schedules for different executions just by changing the YAML file and not by editing the schedule. We can also publish on topics and compare the topics contents with the publish on topic action, and we can also wait for a message to appear to a topic with the wait for action. The action will stay in the running state until a message appears, and we can also compare it to a value. We can wait for it to be greater than a value or equal to a value, and so on. And the last two actions I'm going to mention are the go to pause and the move to joint actions. They have a similar way of operating. The operator, once again, can fill in the corresponding layout a pause, can provide a pause or a joint state, and the robot will move there. For this, of course, an infrastructure is needed. There is a requirement to have a system developed with the intention to be used in that way. Those actions can combine to form diagrams to have a more complex execution flows and control more complex activities. There's also a corresponding layout. This is the layout you see. From the left, in the left portion of it, there can be seen the actions that are available to drop on the layout. And also we have the possibilities here to, of course, delete an element from the grid in case we accidentally dropped it or we want to remove it from the newer version we're probably creating. We can export a diagram to transport port it to different doc instances. For example, I can create a diagram in a PC, export the JSON file, import it to a different PC, to a different facility even, and execute it. And of course, we can edit actions that are already existent in the database. Those diagrams are handled in an interesting way behind the scenes. They are transformed in different diagrams to make the doc capable of executing faster and more efficiently. But I will not dive deeper to this. It gets more complicated, and I think it's out of scope for this tutorial. Now, when dropping an activity on the grid, for example, let's say an action, a box appears. It has different color depending on the abstraction layer. Actions have this blue color, and 4 ports, 2 in and 2 out ports. The all requiring port has the purpose of activating or enabling the activity to execute only when all the requirements that are connected to this port, all the nodes that are connected to this port, execute successfully. For example, on the upper image, in order to lift the ply, both the left and the right grippers need to be activated. You also have the in one requiring port, or the in or port, to activate an action, to start executing an activity using this port. Only one of the connected activities need to complete executing successfully. For example, in the lower image, in case one of the activate left gripper or activate right gripper activities complete execution successfully, the lift ply action will execute. Also, as we can see in this layout, on the upper left corner, there's a manage counters element. This is not an action. The rest of the elements on the left correspond to actions we can create on the create action layout. This, the manage counter element lies there whatever we do. And its intention is to create something like an action, a box that controls the execution flow. We can initialize a counter, alter counter's value, or compare a counter in order to implement loops or various other branches. There's also one more out port we have not mentioned yet, the error port. In case an action does not complete execution successfully, the doc will follow the execution flow indicated by the error port. In case nothing is connected to the error port, the execution will end unsuccessfully, but we can, of course, implement alternative flows. In this example, we can, for example, in case an item is dropped, we can make corrective actions, we can relocate it, lift it again, and try once again to bring it to the destination. This is the last layout provided by doc that I will present today. This is the execution control layout. We can load an action, an activity of the activities we created using the layouts I presented earlier. We can load an activity, execute it, stop the execution, load a different activity, once again execute it. When the activities execute, the color coding shows the execution state. The nodes get yellow while they are running, silver or gray when they completed execution successfully, or red in case of an erroneous outcome. Once again, this layout is intended, this layout's target is to make the doc easier to use and have a greater acceptance by people who do not necessarily have a programming background. I think that's all the capabilities, the features I wanted to present. I'm open to any questions. Okay. I think we can conclude this this presentation. Roma, I think there are no questions.
No question from the audience?
Yes.
Questions?
No, I asked.
I'm so sorry, you're the last one in the day, so that's why no more question.
I hope it's because I explained it fairly well.
Sure, for sure, it was the only explication. So I think it's time to wrap up. Well done. Thank you very much for this workshop. On my side, I've learned lots of things from a guy from material and process composites. It's a different story today. So very interesting and very nice. I've learned a lot. So thank you very much, all of you. So I think it's wrap up the workshop today. So thank you again for the guys who were presenting. And thank you very much, CA, for all the preparatory work and also for the visits and the workshop. So thank you very much. That was very helpful. And in particular for you, Frederic, thank you very much. For those from the project, I think we have a meeting. We have a meeting tomorrow, and also for some of us, we have a diner at 7, so it's nearby. It's 300 meters from here, for what I understood. So there are still some posters on the other side where we have the lunch. With the Anurag, we cleaned everything. So that should be okay, but please, if you have some posters, please you can go and fetch them. So thank you very much, all of you, and it was a great moment today, I guess.
We didn't take a picture, everyone together, and Christina already left, so maybe tomorrow, for those who are here, it would be nice to have a picture all together.
Yes.
Probably last chance.
This evening, maybe.
Yeah, we can take one now and one tomorrow.
Yeah, I think we can take one.
Yeah.
I think Anurag has right.